One day, the Mediterranean Sea will no longer exist. The Strait of Gibraltar, that narrow strip of water you can see across on a clear afternoon, will be gone, and Spain, Portugal, and Morocco will probably become a single, unbroken landmass. This is not science fiction, this is geology. And despite it will only happen in a few million years, the process is already happening right now, beneath your feet as you watch this video. Let's talk about it. Imagine you're holding a giant puzzle. The Earth's surface is like that puzzle, broken into big pieces called tectonic plates. These pieces float on hot, gooey rock deep underground, and they very slowly move around. Now, Spain and Portugal, together called the Iberian Peninsula, are sitting on one of these puzzle pieces, and scientists have just discovered something remarkable. That piece is slowly rotating, like a clock's hand, but incredibly slowly. And here's the thing about a rotating puzzle piece. It no longer fits where it used to. If you tried to push it back in, you'd have to shave off the edges around it. It would be wobbly and imperfect, but eventually it would settle into a new position. The puzzle is never going to look the same again, and if you wanted to hold it all together for good, you'd reach for the strongest glue you have. And once it sets, what were two separate pieces become one single, larger, immovable chunk. That is exactly what awaits Spain, Portugal, and Morocco. Over millions of years, the slow rotation and the relentless pressure of colliding plates will push them together until they fuse into one continuous landmass. A new giant piece of the puzzle that will never come apart again. But let's back up a little, because to understand why this is happening, you need to understand what's actually going on underneath our feet. The Earth's crust is not one solid shell. It's cracked like the shell of a hard-boiled egg that you've dropped on the floor. Those cracks divide the surface into large sections, those tectonic plates we mentioned, and they're constantly on the move. Not fast enough to see or feel or even measure without very precise instruments, but they move. And two of the biggest ones, the African plate and the Eurasian plate, have been on a slow-motion collision course for millions of years. Right now, they're creeping toward each other at a pace of about 4 to 6 millimeters per year. That's roughly the length of an ant. Sounds like nothing, right? But add that up over 1,000 years and you've got about 20 feet, the length of a decent-sized yacht. Add it up over 1,000,000 years and you're talking about up to 3.5 miles of movement. The Earth doesn't rush. It doesn't need to. Now, if you open Google Maps and zoom in on the very bottom tip of Spain, you'll spot a tiny little strip of land jutting out toward Africa. That's Gibraltar, the narrow channel of water separating Europe from Africa. And when we say narrow, we mean it. At its tightest point, the strait is only about 9 miles. On a clear day, you can stand on the Spanish coast and see Morocco with your own eyes. Two continents close enough to almost touch, and getting closer every single year. Nobody alive today will ever see them merge, not our children, not our children's children, not anyone's for millions of generations to come. But we're here to think big, so let's keep going. The place where the African and Eurasian plates meet, just south of the Iberian Peninsula, has frustrated geologists for decades. Unlike most plate boundaries, which are sharp, clean, well-mapped lines, this one is blurry and complicated. The two plates don't just collide cleanly here. They grind, they overlap, they push sideways, and the result is a messy zone of stress and deformation that scientists are still trying to fully understand. To get a better picture, a team of researchers combined two types of data: readings from GPS satellites orbiting the Earth and records of earthquakes that have occurred across the region over recent decades. By looking at how the crust is being squeezed and warped at that boundary, they were able to map the underground stresses. And what they found confirmed something that had long been suspected but never clearly proven. The Iberian Peninsula is performing a slow, clockwise rotation. Here's why, and this is where it gets really interesting. Just east of the Strait of Gibraltar, there's a geological structure called the Gibraltar Arc. Think of it as an enormous underwater mountain range that curves in a wide arc, like a bent arm, connecting the mountains of southern Spain on one side and the mountains of northern Morocco on the other. The Baetic Cordillera runs through southern Spain, sweeping from the coast near Cadiz all the way to the Sierra Nevada. On the African side, the Rift Mountains in northern Morocco form the other end of this arc, and between them, mostly submerged beneath the sea, lies the arc itself. Now, this structure is not sitting still. The entire Gibraltar Arc is slowly drifting westward, toward the Atlantic, and as it moves, it stretches and curves, almost like a slow-motion wave rolling toward the ocean. And here's the crucial part. As it does that, it acts like a natural shock absorber. All that enormous pressure generated by the African and Eurasian plates grinding into each other, east of the strait, the Gibraltar Arc soaks most of it up. It takes the hit so that the rest of the Iberian Peninsula doesn't have to. The stress gets absorbed into the arc's own deformation rather than transmitted further inland. But west of the strait, the arc's protection runs out. There's no buffer, no shock absorber, nothing standing between the two colliding plates and the southwestern corner of Iberia. The African plate pushes directly into it, like pressing hard on one corner of a revolving door, and that uneven pressure is precisely what causes the whole peninsula to rotate clockwise. The east is somewhat shielded, the west is getting pushed, and the result is a slow, grinding twist that's been building for millions of years. Now, you might be thinking, okay, fascinating, but what does any of this have to do with my life? Fair question, but here's the thing. You might be closer to this than you think. The most direct way these tectonic forces make themselves known is through earthquakes. The southwestern part of the Iberian Peninsula, around Cadiz, Sevilla, and southern Portugal, is one of the more seismically active regions in all of Western Europe, precisely because of this pressure, and historically has already shown us what happens when that pressure gets released all at once. In 1755, Lisbon was hit by one of the most catastrophic earthquakes ever recorded. It leveled the city, killed tens of thousands of people, and sent a tsunami rolling across the Atlantic Ocean. That earthquake was a direct product of the exact same tectonic forces this research is describing. Beyond earthquakes, the movement shows up in subtler ways too. GPS satellites are now sensitive enough to detect that specific points on the Iberian Peninsula are shifting by a few millimeters every year relative to the rest of Europe. And the mountain ranges of southern Spain, the Sierra Nevada and the Beatic Cordillera, are still being actively pushed upward by this compression. They're technically still growing, just far too slowly for anyone to notice. The same goes for the Rift Mountains across the water in Morocco. The rotation is happening all around us. It's just that most of its consequences play out on a timescale that makes an entire human life feel like a single frame in an extraordinarily long movie. And the ending of that movie? The Mediterranean Sea gradually closes. Africa and Europe join at the western end. The Strait of Gibraltar disappears, replaced by mountains and rock and a continuous landmass stretching from Scandinavia all the way to the Sahara. It sounds almost impossible, but the forces making it happen are already at work. Right now, beneath your feet, one ant's length at a time. Africa is ripping itself apart. A giant crack is tearing through the continent and stretching south like a zipper being pulled open. And it's happening faster than anyone expected. Now, scientists think the main trigger might not be buried deep inside Earth, but up in the sky. That's right. What might be speeding up this breakup process is the region's drying climate and brutal droughts. And that feels off, right? Usually tectonic plates move first and the climate changes afterward. But in East Africa, it might be flipped. The climate may actually be helping the plates pull apart faster. But first, let's look at what's really going on there. So, Earth's crust isn't one solid shell. It's made of giant tectonic plates, massive slabs of rock that never stop moving. They grind past each other, collide, slide under, climb over, or stretch apart. This motion is so slow, we don't notice it. But over long periods, those tiny shifts reshape continents, just like what's happening in Africa. For about 30 million years, the Arabian plate has been moving away from the African plate. That slow pull split the land. The seawater rushed in to fill the gap, forming the Red Sea and the Gulf of Aden. And that's not the only breakup happening there.
In eastern Africa, the Somali Plate is stretching away from the Nubian Plate. This is opening up the East African Rift Valley, cutting right through places like Ethiopia and Kenya. The region where these plates meet has a name. It's a triple junction. But in this case, they aren't crashing into each other. All three tectonic plates are diverging. When that happens, the crust gets pulled in different directions at once, like fabric being stretched from three corners. It weakens, thins out, and cracks open. They're pulling apart at different speeds too. The Arabian Plate is moving away from Africa at about an inch per year. The two African plates are separating more slowly, roughly between half an inch and 0.2 inches per year. And as they open that gap, hot material from deep inside Earth rises up and hardens, creating brand new seafloor along the split. I know, a few inches per year sounds ridiculously slow, but what makes this event so fascinating is that we're watching it happen in real time. We can actually see Africa slowly breaking apart, and it's terrifying. Back in 2005, a 35-mile long rift that opened up in the Ethiopian desert. The crack is 20 feet wide in some places, which is roughly the size of a shipping container. This is just one example of how active the region really is. From space, satellite images show valleys and rifts slowly widening over time. And down on the ground, people are posting videos of places where the Earth has already split open, leaving big cracks and gaps. Roads, houses, even schools are getting torn apart. The whole area keeps shaking from earthquakes, and the volcanoes are very active. What I mean is, even though this splitting process is super slow, we can actually see it happening, and it's unstoppable. Experts believe this crack in the East African Rift Valley will become a gateway. Waters of the Indian Ocean will eventually invade the valley and fill the growing gap. That will help pull the land apart even more, and eventually it'll create a brand new ocean. And we know that can happen because Earth has done it before. That's exactly how the Atlantic Ocean formed about 180 million years ago, when South America and Africa pulled away from each other. If the East African Rift keeps opening up, parts of Eastern Africa, Somalia, Kenya, Tanzania, Mozambique, and a big chunk of Ethiopia could one day break away from the rest of the continent. That means countries like Zambia and Uganda could actually end up with brand new stunning coastlines. But don't pack your swimsuit yet. Unfortunately, none of us will be swimming in the waters of this future sixth ocean anytime soon. Scientists estimate the full split would take about 5 to 10 million years. That's basically forever in human terms. But in Earth terms, it's surprisingly fast, almost like record speed. Now, scientists are trying to figure out why it's happening so fast. I mean, faster than it should. And here's a new intriguing possibility: a drying climate. One of the biggest clues starts right here at Lake Turkana. This lake in Kenya is about 19 miles wide, and it's up to 400 feet deep in some places. But that's nothing compared to more than 5,000 years ago, when the lake level was up to 500 feet higher. Back then, the continent was going through something known as the African Humid Period. It was a time when Africa was wetter than it is today, and the Sahara wasn't a desert at all. It was green, wet, and full of lakes, rivers, and vegetation. But since then, the whole region has shifted into a much drier phase. So researchers took sediment samples from the bottom of Lake Turkana to figure out past water levels and how sediment washed into the lake over time. And while they were doing that, they noticed something else. Those sediment layers preserved lots of tiny faults and even the fingerprints of ancient earthquakes. Wait, wow! That means Lake Turkana might not be a simple lake. It could actually be one huge crack in the earth that eventually filled up with water. In other words, it could be a direct result of this whole rifting process. And now scientists think the same thing might be true for other deep, narrow lakes in the region, like Lake Malawi along the Tanzania-Mozambique border. So, scientists came up with a wild theory. What if these lakes are helping split Africa apart faster? Okay, maybe the theory isn't that wild. After all, water can indeed affect tectonic plates. For example, when glaciers melt and disappear, all that weight is removed, and the land underneath slowly pops back up, kind of like bread rising after you take something heavy off of it. That's called isostatic rebound, and big amounts of water can do the opposite. They press down on the crust, which can also affect things like faults and earthquakes. At Lake Turkana, something interesting shows up in the data. After the African humid period ended, the faults around the lake started moving faster, by about 0.007 inches per year. I know, that's a lot of zeros. But over thousands of years, that extra push can add up. And it could help explain why earthquakes might be more common in the region today than they were around 8,000 years ago. The study then ran computer simulations and found two likely reasons the shaking and fault movement sped up. First, there's less water pushing down on the ground. With that weight gone, the faults can slide more easily, like loosening a vise that was squeezing two pieces of wood together. Second, there's a volcano on an island on the south side of Lake Turkana. Deep underground, it has a pocket of hot, molten rock. When the lake level dropped after the African humid period, the pressure on the earth below eased up, like taking the lid off a pot. That lets the rock underneath melt a bit more. The extra melt flows into the volcano's magma chamber, swelling it up like a balloon. And that extra pressure can jolt nearby faults and trigger more movement. So yeah, drought and falling lake levels could be speeding up the splitting process. But it's not like the climate is creating the rift from scratch. It's more like the ground is already under tension, and the climate is giving it a little extra push. The real reason Africa is breaking apart might be related to something called superplume, an enormous column of scorching hot rock rising from deep inside the earth. Think of it like a balloon underground that's slowly filling up. As it pushes upward, it puts pressure on the crust above it. Over time, that pressure weakens the crust and slowly cracks it apart. And even though none of us will be alive to see the final result of this process, it's still amazing to realize that we're watching a continent split, almost in real time. A giant crack, more than 2,000 miles long, is splitting open across Africa. Roads, houses, even schools are getting torn apart. Now, scientists think they've finally figured out what's causing it. An enormous column of scorching hot rock called superplume, rising from deep inside the Earth. And it's slowly pushing the land apart inch by inch. This isn't a small shift though. The continent is breaking in two, and the clue to what's going on could be hidden thousands of miles away in Hawaii. And why does the United States suddenly have a role in all of this? Hang on, we'll get there. First, it's important to know this isn't new information. Africa has been slowly splitting for about 25 million years. This is happening in a region called the East African Rift System. It stretches thousands of miles from Ethiopia down to Mozambique and is the largest active continental rift system on the planet. And by that, I mean places where the Earth's crust is being stretched and pulled apart, causing faults, earthquakes, and volcanic eruptions. Scary stuff to say the least. Back in 2018, for example, a massive crack appeared near a small town just west of Kenya's capital, Nairobi. In some spots, it was about 65 feet wide. That's almost the length of two school buses parked one after the other. The whole thing was terrifying. It happened fast and left a trail of destruction. Roads were cut off, farms torn apart. People were on edge as the ground opened up beneath their feet. And I mean that quite literally. One man watched the crack rip straight through his home. He barely had time to grab a few of his belongings before his entire house collapsed. Sounds terrifying, right? Since it happened in the East African Rift region, panic spread fast. The media was all over it, claiming it was proof that Africa is splitting apart. People standing near the crack thought, oh boy, it's already happening. And many still believe that today. But that's not actually the case. At least not with that particular crack. Because after the initial panic, Videos and photos of it revealed clues that it wasn't related to tectonic plate movement. First clue: the two sides of the crack didn't match. Like trying to fit the wrong puzzle pieces together. They simply didn't line up. Second clue: the gap wasn't one continuous line. There was some kind of soil bridges in between. All this showed it was sudden erosion. I mean, some specialists believe the crack had once been filled with volcanic ash from nearby Mount Longonot. But then the region was hit with heavy rains. When water soaked through the soil, it washed the ash away, leaving the gap exposed. Problem solved. Even after the truth came out, it was too late. This event brought the whole "Africa is splitting" talk back. And here's the thing: even though that crack had nothing to do with it, make no mistake, Africa is breaking apart. That's because the continent sits between two tectonic plates, the Somali Plate in the east and the Nubian Plate in the west. The problem is they're moving away from each other, and as they drift apart, the gap in the East African Rift keeps getting wider. Eventually, the Somali Plate could split completely from the Nubian Plate, creating an entirely new landmass, something on the scale of Madagascar or even New Zealand. You don't have to worry though. This process is super slow. So slow that none of us will see it finished. Experts say the continent is moving apart by about 0.3 inches a year in some places. To give you an idea, that's less than the length of your fingernail. So we can say this split will take millions of years, which is good news for the people living there. But that doesn't mean they won't feel the effects of this slow break. In fact, they're already happening. Take Ethiopia's Afar region, for example. Back in 2005, this area showed just how unpredictable the rift can be. In a short period, 420 earthquakes hit the area, opening up a massive fissure. What usually takes centuries happened in just a few days, completely challenging what scientists thought they knew about the speed of geological changes. Back then, the crack stretched for more than 35 miles, and life around it is still far from easy. Recent earthquakes destroyed much of the local infrastructure. 37 schools were damaged, leaving 5,000 students without classrooms. And that was just one part of the damage. As the tectonic plates keep moving apart, water will eventually flood into this region, creating a brand new ocean, according to some predictions. Countries like Zambia and Uganda, which are landlocked today, could one day have a coastline. That could be great news for them, as it might open up new trade routes and completely reshape their economies. Don't get too excited though. We won't be diving into the waters of this sixth ocean anytime soon. The splitting process will take another 5 to 10 million years. But it's tough to say exactly when, since big seismic events, like earthquakes, could make it all happen faster. So here's what we know. The Somali Plate and the Nubian Plate are in the middle of a dramatic tectonic breakup, slowly moving apart. Africa is breaking in two. Earth will probably gain a new ocean because of it. But until recently, we didn't know exactly what was triggering all of this. Like, yeah, those tectonic plates are moving, but why? I mean, is this massive geological process being driven by something happening in Earth's mantle? Or could it have a much larger, deeper source? Well, scientists think they may have finally cracked the mystery. They believe the continent is breaking apart because there's a deep mantle superplume, a huge column of hot rock beneath the East African Rift system. Think of it as a massive subterranean hammer pushing upward, pressing against the crust, and slowly cracking it apart. But here's the interesting thing. Scientists reached that conclusion thanks to something that happened in a completely different part of the world, Hawaii. Under this US state, there's also a plume of super hot rock rising from deep inside the planet. It melts the crust above it, and that's what fuels Hawaii's volcanoes. As the Pacific Plate drifts over this plume, molten rock breaks through in new spots, creating volcano after volcano. Over millions of years, that's how the Hawaiian Islands were formed. This Hawaiian plume contains noble gases like helium and neon. And you know where else scientists found those same gases? That's right, beneath the East African Rift system. Bingo! That discovery backed up the theory that a superplume is driving what's happening in Africa. And we call it super because it might be massive. You see, these same gases have been found in volcanic rocks from Kenya all the way down to Malawi. So everything points to the existence of a single superplume that stretches from the Indian Ocean to the Red Sea, not a bunch of several isolated sources. If their data and research are correct, scientists estimate that this superplume beneath Africa likely starts at the core mantle boundary, which is located about 1,800 miles deep inside the Earth. While the East African Rift System's chemical signatures are similar to those found in volcanic rocks in Hawaii, they're not identical. The Hawaiian plume is thought to be a narrow, rising stream of hot mantle, a bit like the movement inside a lava lamp. Africa's plume might be shaped differently, more like a large mass of hot, buoyant material rising from deep within the Earth. As it reaches the surface, this hot material hits the colder, solid outer layer and spreads out, pushing hard enough to crack it open and trigger intense volcanic activity across the region. And if this theory is right, we're watching a slow but unstoppable force that will redraw Africa's map and change the continent forever. A long time ago, a huge meteorite smashed into the Earth with a horrible destructive power. It was several times bigger than the one that wiped out the dinosaurs 65 million years ago. Luckily, there were no lives it could have taken, or else it would have been a real catastrophe. Now, scientists think it did leave behind a huge footprint, the massive Antarctica impact crater that is bigger than the entire state of New York. The location also has a gravitational Wilkes-Land anomaly going on. At first, scientists noticed something weird here when they measured Earth's gravity in that region. A strange gravity hole, or a negative gravity anomaly. Later, with better technology, they found something even weirder. There was a positive gravity anomaly inside that gravity hole, a spot with stronger gravity. This kind of structure, called a mascon, short for mass concentration, often shows up in places where giant space rocks or meteorites have slammed into the planet. When a meteor hits hard enough, it punches through the Earth's crust and shakes the mantle below. It can spring back up and leave behind a super dense plug of material, which causes stronger gravity right in the center of the crater. It's something like a frosty donut, with ice filling the gap and a dense center rising up from underneath. In 2018, scientists used advanced scanning techniques to study and map the Wilkes-Land meteorite impact in more detail than ever before. They saw that it wasn't a perfect circle, but more of a U-shape, and the northern part looked like something had broken it apart. It possibly happened when Australia split away from Antarctica about 35 million years ago. Some scientists even think you can still see parts of the crater in southern Australia today. This clue also supports the idea that the giant crater under Antarctica formed before the continents broke apart. There have been different ideas about what created this strange formation. Some said it might be a volcano or an eroded valley, or even a sedimentary basin. That is a place where sediments build up over millions of years. But many scientists now believe the most likely explanation is a massive meteor impact. It was possibly one of the biggest to ever hit Earth. A 2015 study even estimated the age of the crater as its size matches the kind of space rocks that smashed into Earth between 4.1 and 3.8 billion years ago. The Wilkes-Land meteorite impact was so powerful because the meteor that caused it could have been up to 30 miles wide. That's 4 to 5 times wider than the Chicxulub meteor that wiped out the dinosaurs 66 million years ago. Even that meteor was enough to cause massive destruction with wildfires, acid rain, tsunamis, and a climate crash that wiped out about 75% of all existing life. So it was lucky in a way that the meteorite that gave us the giant crater under Antarctica visited at a time when there were only microbes and no plants or animals on Earth. It didn't cause mass extinction or leave behind charcoal from ancient fires, but it may have changed the entire planet. Still,
Scientists haven't put the Wilkes Land anomaly mystery in the solved files because the crater is buried deep under Antarctica's thick ice sheet. It's hard to study up close. Scientists say we can't rule out the other ideas just yet, but if the meteor theory is right, then the Wilkes Land crater could be the largest known impact crater on Earth. So far, this title belongs to another contestant, the Vredefort crater in South Africa. Right now, the crater is around 99 miles wide, which is huge. But it's not as wide as the Chicxulub crater in Mexico, which is about 112 miles wide. But the Vredefort crater used to be way bigger, around 155 to 174 miles wide, before time and erosion wore it down. That means even though the Chicxulub impact was striking, the Vredefort impact was likely even more powerful, the biggest one we know of that hit Earth. According to the latest study, that asteroid was 12.4 to 15.5 miles wide and might have hit Earth at a speed of 45,000 to 56,000 miles per hour. It's important for science because knowing the real size of this impact helps us build better models to understand Earth's geology and how giant impacts shape planets, even beyond Earth. Measuring ancient craters is really tricky. Over 2 billion years, erosion wears away the edges and newer rocks form over the crater. That's what happened to Vredefort. Now, only small bits of the original crater rim are visible, and the rest is hidden under newer rock. To figure out its true size, scientists studied minerals like quartz and zircon found around the crater. These minerals still have fractures and shock patterns that show us how powerful the blast was. Wilkes Land anomaly isn't the only case on our planet where gravity is acting weirdly. For over 40 years, scientists were trying to solve a strange mystery in Canada. Parts of the country, especially around Hudson Bay, seem to have less gravity than the rest of the world. That means if you stepped on a scale there, you'd weigh just a tiny bit less than usual. Researchers first discovered this weird difference in the 1960s when they were mapping Earth's gravity. Gravity is linked to mass. The more mass there is, the stronger the gravity. And since Earth isn't shaped perfectly like a ball but is slightly squashed at the poles and bulges at the equator, it makes sense that its mass isn't spread out evenly. So, the first out of the two main theories to explain the Hudson Bay mystery has to do with magma. Yes, that super hot, gooey rock deep under our planet's surface. Magma constantly churns like boiling soup in a process called convection. As this magma moves, it can drag parts of Earth's crust down with it. That makes the area lighter, which lowers the gravity. The second area has to do with the Laurentide ice sheet, a massive glacier that covered much of Canada during the last ice age. This ice was up to 2.3 miles thick in some parts of Hudson's Bay. That's like stacking 10 Empire State Buildings on top of each other. Because it was so heavy, the ice pressed the land down like a thumb on a sponge. Even though the ice melted away about 10,000 years ago, the land underneath is still slowly bouncing back, kind of like a memory foam mattress after you get up. This slow rise is called glacial rebound, and it's happening at less than half an inch per year. Until the land fully bounces back, which could take 5,000 more years, it will continue to have less mass, and that means less gravity. Both of these theories are right. To figure this out, scientists used super advanced satellites, which floated around 300 miles above Earth for several years. These satellites flew in pairs and detected how far apart they were pulled as they passed over areas like Hudson Bay to measure tiny changes in gravity. When the front satellite passed over a low-gravity area, it drifted just slightly, and that change was recorded. Thanks to this research, scientists created detailed maps showing what Hudson Bay looked like during the last ice age. They discovered two huge bulges on the west and east sides, where the ice was thickest. And those spots have the weakest gravity today. The effects of this are still visible, and while sea levels are rising in most parts of the world, the land around Hudson Bay is rising so fast that sea levels there are actually dropping. Solving mysteries like this or the Antarctica impact crater anomaly gives scientists amazing insights into the past of our planet. And by understanding how past changes in temperature and geology affected Earth, scientists can predict how today's human activity can impact our future.
Surprise! There's more than 7 continents on our planet. Argoland, a hidden continent, may help us understand how our planet will look in the future. To find out how it hid from us and what secrets it holds, well, you'll just have to keep watching. Ready for a mystery? Scientists have been looking for a piece of land that's been missing for over 100 million years. Not exactly newsworthy, since people search for information about our planet's history all the time. You'd think it was probably this minuscule island somewhere in the middle of an ocean. Well, you'd be wrong, because this continent used to be as big as the entire U.S. territory. For a long time, geologists have been wondering whether a massive chunk of contemporary Australia vanished into thin air. Some believed it was simply hiding somewhere on the ocean floor. But thanks to some Dutch specialists and 7 years of investigating, we now know there are bits and pieces of this lost land mixed underneath the lush jungles of Southeast Asia. The continents we see in our geography manuals these days are like scattered pieces of a puzzle. There's even a nice experiment you can conduct to see for yourself. Find a world map online and print it out. Cut out all of the continents and play around with them for a while. You'll see they all fit together. Probably the most striking thing you'll see is how South America perfectly fits near Africa. If you close up the oceans that were formed in the last 200 million years, the continents look like they form a giant letter C. And that C is what scientists call the supercontinent Pangaea. It was swimming in an ocean called Panthalassa, and the inner portion of that letter C had a smaller stretch of water called the Tethys Ocean. It is in this small ocean where things get interesting. Back in the Jurassic period, this vanished continent, which scientists started calling Argoland, vanished and left a hole in Australia, now known as the Argo-Abyssal Plain. Geologists initially believed this was all due to a process called subduction. It's when one piece of the Earth's crust dives under another and recycles it into the planet's mantle. Usually, specialists track this continental vanishing through off-scraping. That's how they figured out, for instance, that India bumped into Asia and gave us the majestic Himalayan mountains. But for Argoland, things were a bit more complicated. Bits and pieces were popping up in places like Myanmar and Indonesia, but they behaved like these time-traveling relics, looking way older than when Argoland supposedly separated from Australia. It immediately raised the question: if one continent can behave so weirdly, how many others are out there doing the same? Thankfully, scientists have now put together the entire timeline of Argoland and figured out its mystery. It didn't sink or get swallowed up. It simply transformed into an archipelago, breaking into smaller pieces, called microcontinents, and floating away from Australia. These mini-continents then took a little journey before settling down in Southeast Asian jungles. This discovery fits right into the whole Pangaea puzzle. It helps us better understand how continents break up and make up, all in one discovery, revealing secrets of biodiversity and climate back from in the day. If you'd like to find out more secrets about history, civilization, or random day-to-day objects, be sure to like this video and subscribe to the channel. Like, for instance, the mystery behind this invisible species line in Indonesia. It's called the Wallace Line, named after the British explorer Alfred Russel Wallace. Over 150 years ago, Wallace was on a journey around the Malay archipelago, visiting thousands of islands. What he found was that animals on one side of this invisible line were considerably different from ones on the other side. This invisible line is like a wall between marsupials and tigers, for instance, or honey-eaters and trogons. But now we know that around 35 million years ago, Australia broke up with Antarctica and collided with Asia. And this continental love triangle triggered significant changes. It didn't just change the way the land looked, it also messed with the species of animals on each side of the Wallace Line. In more recent times, a bunch of specialists published a study saying this collision and climate chaos made Asian species comfy living in the Malay archipelago. Meanwhile, the Aussie animals weren't as happy with the new environment. It was too hot and wet for some, and others just couldn't handle the tropical island lifestyle. The discovery of this continental shift towards Asia might also explain a recent finding of a human species that didn't seem to make any sense either. You see, in this hidden cave in the Philippines, archaeologists stumbled upon a new human ancestor. It seems that about 50,000 years ago, on the island of Luzon, there was this ancient human-like species. The lead researcher believed this finding was crucial for understanding human evolution in Asia, and it named this new species after the island, Homo luzonensis. Now, here's where it gets a bit confusing. The bones found by archaeologists had one small problem. They had a weird mix of traits that hadn't been seen together in any other hominid species. Smaller teeth, similar to ours, yet hands and feet that were more like our ancient humanoid ancestors. It was those throwback limbs in particular that connected this human species with the long-lost Southern Territory. That's because they have this primitive look, like these hard-to-pronounce guys, for instance. Only these two species are separated by 2 to 3 million years of time in evolution. Many have wondered, is Homo luzonensis really a new species? Not everyone is convinced. But it may also explain why living creatures are also affected by the constant shifting of the land underneath us. Now, just because they haven't changed much during our lifetime, it doesn't mean our continents will look like this forever. They evolved from this large megacontinent, and they'll most likely end up in a similar position in the future. On that note, a geologist from a European university tried to predict the future of Earth's supercontinents. As a starting point, he used an earthquake that occurred in Portugal back in 1755, when tectonic plates behaved a bit differently than they should have. After years of research, he came up with a theory in 2016. He believed that the stitches between these tectonic plates might be coming apart, setting the stage for a bigger rupture. It's like when glass cracks between two holes in a car windshield. If this happens, a subduction zone could stretch from the Mediterranean all the way up past Ireland, bringing volcanoes, earthquakes, and new mountains to these areas. If all goes according to this plan, the Atlantic Ocean will disappear, and so will the Pacific, turning into one large stretch of water. Instead of the 7 continents we know today, we'll get a new supercontinent, which he called Arica, because it would have Australia and the Americas at its heart. Now, it's not the only possible scenario, though. Novo Pangea might be another, and it's easy to foresee. The Atlantic stays open and the Pacific closes. Then there's Amasia. For this one, you'd have to imagine the Arctic Ocean closing and the Atlantic and Pacific staying open. Everything shifts to the north around the North Pole, except Antarctica. One final scenario would be called Pangea Ultima. Slow down the spreading in the Atlantic, and a new subduction plate pops up on the America's east coast. Well, either way, if all the continents collide in the future once more, some say it won't be fun to experience. It's believed that in around 250 million years, we'll feel like we're being trapped in a sweltering, soggy plastic bag. Weirdly, that bag will be the best place to live on Earth, the coastal areas. As for the inland spots, they'll be sizzling, like a desert on fire. Many of the species of animals we know today might not make it. As for us humans, we'll need to be creative if we want to withstand the heat. We should be thankful, though. These digital models are still great because we can use them to test all sorts of interesting ideas. For example, how these supercontinents would mess with tides. Taking future space travels into consideration, these models can help us understand the climates of exoplanets too. Those are located outside our solar system.
Lake Kivu is a ticking time bomb. Massive pockets of carbon dioxide and methane are trapped deep below. They've been building up for hundreds of years, and if they ever burst to the surface, it could trigger the most powerful limnic eruption on Earth.
That's an insanely rare event where toxic gases erupt from deep lake waters without warning. If it happens at Lake Kivu, it could blast 2.6 gigatons of carbon dioxide into the air. This toxic fog would fill the surrounding valley and suffocate anyone who walked into it. People wouldn't scream or ask for help. They'd just collapse within a minute. This is especially concerning as nearly 2 million people live near Lake Kivu. And the scary part is, no one really knows when it will happen. That's because a lot of things could trigger this catastrophe. Basically, anything that stirs up the deepest layers of the lake, like rock slides, lava pouring from nearby volcanoes, or, ironically, even the very things authorities are doing to prevent it. Because, to make Lake Kivu safer, they need to install pipes that slowly release the gas from the bottom. That sounds like a win-win, since the methane they pump out can power Rwanda's electric grid. And estimates say the methane in Lake Kivu could be worth up to $42 billion over 50 years. But this plan is also controversial. Numerous studies say that methane extraction might not be safe, and some scientists worry it could disturb the lake and trigger the very eruption this plan is supposed to prevent. Truth is, this process is really new, and we still don't know how the lake will behave. So people living nearby are worried, scared, and anxious that a disaster could happen at any time. They say there are warning signs around the lake, but no real evacuation plan if disaster strikes. And the danger just keeps growing, with more and more buildings popping up along Lake Kivu's shores. We know this isn't just science fiction, because it's happened before. More than once, actually. In 1984, Lake Manoon, an isolated lake in Cameroon, suddenly released gas and took the lives of 37 people. Then in 1986, Lake Nyos did the same thing on a much larger scale. A toxic white mist spread through the area, and by morning, over 1,700 people had lost their lives. In both cases, scientists didn't see it coming, and probably because they thought it was impossible. This is a rare event, and back then, nobody really understood it. But now we have no excuse. And if nothing changes around Lake Kivu, we could end up witnessing the biggest disaster of its kind. Nearly 140 years ago, some fishermen pulled pieces of a ship from Lake Michigan. But where was the rest of it? From that moment on, hunters spent years searching for the ghost ship. By the 1970s, the hunt reached a new level. One with a $1,000 reward offered to anyone who could find it. Still, nothing. It was as if the vessel had simply vanished into thin air. That is, until now. Researchers have finally found the shipwreck off the coast of Bailey's Harbor, Wisconsin. The ship called the F.J. King disappeared back in 1886. At that time, this 140-foot-long vessel had a very important job: transporting grain. Now you might think, grain? Really? That's it? Okay, sure, it's not like the ship was loaded with tons of gold or jewels. But we have to see the bigger picture. At that time, Wisconsin was known as America's breadbasket. The state produced huge amounts of food, especially wheat. In fact, about 1/6 of the nation's wheat was being harvested there. Farming was booming, and that of course meant big money. The F.J. King was part of that golden era.
For about 19 years, it successfully carried and traded grain and iron ore through the Welland Canal. That is, until September 15th, 1886. That day, the crew were on their journey to carry iron ore from Michigan to Chicago. It was supposed to be just another routine trip, but they were caught in a powerful storm. The conditions were brutal, with waves nearly 10 feet high. The crew fought desperately to get the water out and keep the ship afloat, but the waves were too strong. They kept coming, one after another. The men worked hard until they couldn't go on anymore. The waves were splitting the ship's seams. At this point, a catastrophe was inevitable. So Captain William Griffin gave the order, "Abandon ship." They had no choice but to get out. The men grabbed their belongings as fast as they could and climbed into the ship's small yawl boat. It was 2 in the morning. Everything around them was dark. As they tried to get closer to shore, the FJ King went down, bow first. And then suddenly, boom! The crew watched in shock as the ship's stern deckhouse blew off, sending the captain's papers 50 feet into the air. They stayed in the small boat until they were picked up by a passing schooner called La Petite. The crew took them to Bailey's Harbor, and moments later, Captain Griffin filed a wreck report. That's when the real mystery began. In his report, the captain said the ship had gone down about 5 miles off the shore of Lake Michigan. But that was just what he thought. I mean, it wasn't based on any instruments, readings, or anything like that. It was just what he remembered from that night. A week later, though, a local lighthouse keeper spotted the masts of a schooner sticking out of the water, much closer to shore. He reported it to a nearby newspaper, and that's when people really started asking questions. Could that be the FJ King? Even though they had a solid lead, it didn't take them anywhere. No one could find the boat. Days passed, then months, then years, until 2025. That's when an investigator named Brendan Baylod decided enough was enough. He gathered a team of about 20 scientists and historians to finally track down this historic shipwreck. They dug through hundreds of original documents about the ship and the day it went down, piecing together clues and narrowing down the area where it might be. Many experts were like, "Man, just let it go." And to be fair, they had every reason to feel discouraged. After all, that whole area had already been searched over and over. There was just no way the ship could still be out there. But Bayod didn't give up. Okay, truth is, he also thought it was a long shot. But working to find the ghost ship had other perks. His team wanted to get some hands-on experience with a brand new super advanced sonar. With that in mind, they set out on their mission, heading to Lake Michigan on June 28th. Okay, great. But where do you even start? First, Bayod had to clear something up. Back when the wreck happened, who was actually telling the truth about the ship's location? The captain or the lighthouse keeper? Getting that answer would point them in the right direction. Then, Bayod thought about something that might have already crossed your mind. How could the captain really know where they were? It was pitch black. He'd just been struggling to keep his ship afloat. He couldn't see much. He was exhausted and probably hungry. He definitely wasn't thinking straight. That's when the investigator realized the lighthouse keeper's directions were probably more accurate. Thankfully, he found the newspaper article from 1886. You know, the one I mentioned earlier, where the lighthouse keeper gave a more specific detail about where he'd last seen the ship's masts. What the investigator did next was draw a 2-square-mile grid around that location, and the team decided to map the lake bottom inside that grid using their fancy tech. So, there they were, aboard the Shoreline, a tour boat that usually carries sightseers along the peninsula. But that day, they didn't really expect to find anything. Their only goal that afternoon was to test their new side-scan sonar, one with much greater capability than the previous model the crew had been using. But then, after about 2 hours of searching, something strange happened. The sonar was sending out sound waves to map the dark floor of Lake Michigan when it started to act a little differently. And as the images began to stitch together, they revealed a shape that was impossible to mistake. A ship. Bingo. They'd found it. Turns out the wreck was less than half a mile from where the lighthouse keeper had said it would be. At this point, some of the crew had to pinch each other. They couldn't believe their eyes. They were shocked, not only because they'd found the ship so quickly, but also because of how well it was preserved. You see, the investigators were hopeful, but they also thought the ship would be shattered into pieces. After all, it had been carrying iron ore, and the weight of all that metal could have torn it apart even more. But no. To everyone's surprise, the hull was almost completely intact. Sure, the front right side was crushed, but the rest of it was pretty much there. The investigators even found the crew's belongings and kitchenware scattered across the lake bottom. Once they got over the shock, they called in archaeologists to examine the site and create a 3-dimensional model of the wreck. This is the 5th major shipwreck Bayod and his team have found in the last 3 years. But the truth is, this region is full of mysteries still waiting to be uncovered. The F.J. King is just one of around 6,000 ships that were damaged or destroyed in incidents across the Great Lakes during the 1800s. And it's estimated that hundreds of these wrecks still remain hidden at the bottom of Lake Superior, Michigan, Huron, Erie, and Ontario. Thankfully, discoveries like this one could become more and more common. In fact, more shipwrecks are being found today than at any other time in history. Advances in technology have made scanning the lake floor less expensive and more accessible, not just for professionals, but for amateurs too. And the profile of these modern-day shipwreck hunters has changed. Now, they're more often searching for wrecks for their historical value, not just to find treasure. Another project that could help uncover even more wrecks in the Great Lakes is called Lakebed 2030. It could change everything, as its goal is to map the entire lake floor. And right now, only about 15% has been explored. That means the Great Lakes might still be hiding their biggest secrets, and that, at the very least, is super exciting.
Well, this eerie Lake Huron discovery may be that it possibly contains the remnants of an entire civilization. Whoa, wait, sounds like Atlantis, right? Well, not exactly. But if there really had been an ancient underwater civilization here, it must have been a pretty advanced one. Around 10,000 years ago, two sharp glassy flakes broke off a stone tool and landed on the ground unnoticed. They stayed buried there for thousands of years, until 2013. Then scientists pulled up a small chunk of mud, about the size of a milk carton, from the bottom of Lake Huron, 100 feet underwater. Inside the mud, they found those same two flakes made of obsidian, a shiny black volcanic glass that forms when lava cools quickly. After careful testing, they realized these flakes came from Central Oregon, which is quite a distance, about 2,500 miles away. They found this prehistoric Great Lakes site on the Alpena Amberley Ridge, an underwater landform that once connected what's now Michigan and Ontario. Back then, it was dry land. Early humans used it to build traps for animals like caribou as the Ice Age faded and the Great Lakes began to form. Now, obsidian was the high-tech material of ancient times. It's super sharp and perfect for making tools. If you study the flakes carefully, it's obvious that humans made them. You can see where they struck them and the feathered edges that come from being carefully chipped. That means people were not only crafting tools here, but they also had access to obsidian that came from incredibly far away. It was likely possible through a huge trade network that spanned across the continent. For over 100 years, people have guessed that ancient societies might have existed beneath the Great Lakes, but no one had proof. That's why work on this submerged archaeological site is so important. A team of researchers has been trying to learn more about the 10,000-year-old ruins and the civilization that left them behind for over a decade now. Lake Huron's icy water acted like a time capsule that helped preserve things for thousands of years. So far, researchers have found not only unique stone tools, but also ancient trees with roots still intact and underwater peat bogs that preserved seeds and leaves. It was like an Ice Age version of Pompeii, a scene frozen in time. These discoveries are also helping scientists create new technologies and ways to do underwater archaeology. They've engaged sonars, underwater robots, and divers so far. Now, it's pretty cool that the tools they found on the Alpena Amberley Ridge were way smaller than other tools from the same era found nearby. That might mean a different group of people lived here, and they had their own unique way of life. Even the peat bogs they found, which are about 9,500 years old, hold secrets. They're full of pine needles, seeds, and leaves that could reveal what the environment was like back then. Usually stuff like this breaks down quickly on land, but the cold freshwater preserved it. The Michigan team is working with scientists in Cambridge, England, to extract DNA from the remains. If it works, it could finally confirm what animals lived there, and maybe even more. There are still years of discovery on this prehistoric Great Lakes site ahead. Another famous submerged archaeological site is the lost city of Pavlo-Petri. Archaeologists think it is the oldest sunken city in the world they've found and made official so far. Pavlopatri is around 5,000 years old. That means it existed even before the legendary Greek heroes in Homer's stories. Scientists first spotted it way back in 1904, and then mostly forgot about it until 1967, when Nicholas Fleming rediscovered it. He described it as a Bronze Age city now lying under about 10 to 13 feet of water. A year later, he returned with a team of scientists to study the ruins. Over 6 weeks, using just hand tapes and a basic grid, they managed to map out the city. They found that it covered almost 1,000 feet by 500 feet and had at least 15 buildings, courtyards, 5 streets, 2 tombs, and around 37 small stone graves. They also found signs that the ruins continued onto the nearby island of Pavlopatri itself. They dug up some amazing pottery, obsidian, and chert blades, and even a tiny bronze figurine that may date all the way back to 2800 BCE. Most of the buildings, though, came from the period between 1650 and 1180 BCE. Then scientists left the site alone again until 2009, when a super team of researchers launched a new 5-year project to really dive deep into the history of Pavlopatri. This time, they had digital mapping tools and better diving equipment, so they could explore and even excavate underwater. They found another 97,000 square feet of buildings, including a large hall and hidden streets. Plus, they dug up even more pottery that showed people had been living in the city from about 3000 BCE to 1100 BCE, and that the city once had a population of 500 to 2,000 people. No one knows for sure how the city ended up underwater, but many scientists think it was because of an earthquake, maybe around 1000 BCE, or even as late as 375 CE. Because it's the oldest underwater city ever found, some people even believe Pavlopatri might have inspired the legend of Atlantis. Another contestant for the Atlantis title lies near Japan. Back in 1986, a local diver was exploring the waters near the Ryukyu Islands when he found a giant structure made of perfectly shaped steps and sharp edges. It was 82 feet underwater. Today, the Yonaguni Monument is one of the most mysterious underwater sites on the planet. The structure is nearly half a football field in size. It looks like a massive stone pyramid with layers of platforms and steps stacked one on top of another. No one really knows where it came from or who built it. Some experts think the monument might be more than 10,000 years old, which would make it older than the Egyptian pyramids. One theory is that it could be the last remains of a lost civilization called Mu, a mythical Pacific society kind of like Atlantis. Others believe an ancient culture that lived in Japan as early as 12,000 BCE might have built it. But many scientists and geologists are skeptical about this possible underwater ancient civilization, even though Yonaguni has narrow passageways, arched openings, and right angles that almost look like city blocks. They say that the site looks a lot like natural rock formations, like the Giant's Causeway in Northern Ireland, for example. The whole monument is still connected to a bigger chunk of bedrock, which means it wasn't built piece by piece. And the way the layers of rock are stacked probably has more to do with earthquakes and tectonic movement. It's located in the very active Pacific Ring of Fire. One marine geologist kept going back down there, and every time he found something new. He says he spotted tool marks in the rock, symbols carved into stone faces, and even rock formations shaped like animals. He believes these carvings point to a culture that came from mainland Asia. He said he had identified 10 different structures off Yonaguni, including a ruined castle, a triumphal arch, 5 temples, and even a huge museum. These buildings seem to be connected by roads and channels, and some parts are surrounded by what could be giant stone walls. The explorer believes the city is at least 5,000 years old, based on stalactites found in underwater caves nearby, which would have only formed after the caves flooded. His supporters say they have never seen an earthquake create shapes like this, above or below water. But skeptics blame it all on erosion and insist that whirling underwater currents and sea creatures left holes in the rock. Now, if you want to form your own opinion about it, the spot is open for visitors, and it's definitely a super fun diving experience. Do you know what one of the most dangerous and scary lakes in the U.S. looks like? Let's check it out. This large lake is filled with blue water reflecting the sun's rays. Lush thickets of oaks and other trees surround this picturesque place. More than 150 small islands, which are the tops of hills, stick out from under the surface. People come here to swim and play frisbee, go boating, and sit quietly on the sand. Nothing dangerous, right? But if you dive underwater with scuba gear and start exploring the seabed, you'll see that it hides old fishing nets, broken sunken boats, debris of houses, and even graves. If you go to the local library and start researching the history of this place, you'll find out that many people were kicked out of the area against their will. You'll learn that there were terrible conflicts between locals here. You'll understand that the idyllic picture hides a terrible drama and hundreds of tragic fates. This is Lake Sidney Lanier, which is in North Georgia. It was named after writer Sidney Lanier, who created the poem Song of the Chattahoochee, dedicated to the river that feeds the lake. Despite the beautiful view, this isn't a natural body of water. Sidney Lanier is an artificial lake created in 1956 to fight floods caused by the river, to provide people with drinking water and hydroelectric power. The perfect place for creepy stories that often happen in small American towns. Before people created the lake, about 700 families inhabited this place. They made up a classic quiet village with farms, houses, churches, mills, and a cemetery. But when the state decided to create a lake here, the authorities forced people to leave their homes. Locals had lived here with their families for generations, and then they had to go away. Most of the buildings were moved, but the cemetery was left untouched. The graves are still there at the bottom, while people on the surface are swimming and having fun. 200 years before the lake appeared, the Cherokee tribe had lived in this place. In the 1830s, they also got kicked out of their territory. Then, in the first half of the 20th century, there was a very big conflict between locals. The reasons for the conflicts are quite scary, so we won't dwell on them. But it's important to note that more than 1,000 people got hurt by this conflict and were forced to leave their homes. So, we have a place where tragic episodes have happened 3 times, and where a lot of people have been injured throughout history. Of course, there's no scientific evidence that those events had any effect on the lake. But if we talk about spiritual, karmic plane, then see for yourself. Lake Lanier is considered one of the most dangerous lakes in history. 500 people have drowned or disappeared here since 1956, and almost 200 since 1994. About 11 million tourists visit the shores of the lake every year. About as many people visit the Louvre Museum in Paris. But don't think that accidents happen here because there are too many people there. A few dozen miles to the west, there's another popular lake, Altoona, and the same number of tourists come there every year. But there are almost 3 times fewer accidents there. For some reason, people drown at Lake Lanier, and motorboats often collide. There are no seasons with more or fewer accidents. So the cause of these tragedies may be hidden underwater. Many sunken boats, fishing nets, flooded villages, and graves lie at the bottom. Perhaps when someone dives here, they get tangled in nets, or stuck among debris or bump into rocks. Motorboats may not notice tourists passing by on air mattresses and crash into them. The water in the lake isn't very transparent, which makes it difficult to search for the missing. And then, there's also the legend that spirits inhabit this lake. Locals talk about phantoms who come out of the graves and try to pull the living under the water. Others tell stories about 27 ghosts of those who drowned in the lake over the years, but whose bodies haven't been found. But the scariest legend is probably the one about the Lady of the Lake. In 1958, 2 friends, Delamay Parker Young and Susie Roberts, got into their car. They drove to the gas station, refueled the car, didn't pay for the gas, and went to the lake. The evening started fun, but it turned into a terrible night. The girls drove off the bridge when they were crossing the lake and disappeared. For an entire year, no one knew what had happened to them, but people thought that the lake had taken them. One day, a local fisherman went to the lake to catch some fish and suddenly noticed a body in a blue dress floating near the bridge. It was poorly preserved, so the examination couldn't determine the identity of the person. But many locals were sure that the body belonged to Parker Young. Some people saw that day that she borrowed this dress from Roberts and put it on. But where was the other girl? And why was there no car? A few decades later, in 1990, authorities discovered an old Ford sedan at the bottom of the lake. They extracted the car and found the body of Susie Roberts inside. After this tragedy, locals started telling scary stories about how a transparent Parker Young in a blue dress grabs passers-by by their clothes and tries to drag them into the water. So, what do we have now? 3 terrible events have occurred at this lake over the last 200 years, affecting thousands of people. There's an old cemetery at the bottom of the lake, which the authorities decided not to move. 2 girls drowned there. At first glance, these events are not related to modern accidents. But honestly, we all feel and understand this connection inside. Places with such heavy energy and such a past may influence the present. Some skeptics will argue with this, but let's be honest, hardly anyone will buy a house when something terrible and tragic has happened. Today, Lake Lanier is more popular than ever. Millions of tourists, beautiful views, and picnics. Nothing suspicious, but you should still be careful. Just open the internet and read about the accidents happening there. Those missing people didn't expect their vacations to turn into a tragedy, so be very vigilant if you decide to come there. Now let's finish our video with something mysterious but more upbeat. How about the Vanishing Lake in Northern Ireland? You come there, swim, take cool pics, and decide to come back for a picnic with your friends. You come the next day with your homies, but hey, there's no lake. It's gone. Your friends are so angry. They come all their way there because of a silly prank. You feel like you're going crazy. Well, calm down. You're fine. There was a lake. In fact, it's still there. It just has a curious geological quirk. 3 streams fill this lake, but none of them can flow out. The lake fills up quickly, and then, when it reaches a certain point, it just flushes away, like the water in a toilet bowl. There are gaps at the bottom of the lake that are clogged with peat and debris. They act like bath plugs. But when there's too much water, these plugs fly out and the lake goes underground. So relax and come here another day when it's filling again. The road that leads to the lake is slightly raised off the ground so that people can walk along it. Previously, this road went underwater and reappeared. And don't be surprised if one night you see an old horse-drawn carriage on this road. It does look scary and creepy. Legend says that more than 100 years ago, a carriage with horses was crossing this lake when the water level was high. The carriage sank, and locals have been telling scary tales about the phantom ever since.
Lake Michigan is one of the largest and most mysterious freshwater lakes in the United States. And now, deep inside it, scientists have stumbled upon something unexplainable. Vast, round craters scattered all across the lake's floor. It all started in 2022. A team of researchers wanted to map the lake's bottom and look for some shipwrecks. At first, they were sure it's going to be just some typical rocky terrain or sandy patches. But what they saw on their sonar screens stopped them cold. Strange circular shapes that looked almost too perfect to be natural. They were hiding about 500 feet beneath the surface, in places where the water turns dark and impenetrable. Those guys are huge, ranging from 300 to 600 feet wide. They also plunge nearly 40 feet deep. And there are dozens of them, neatly arranged like some footprints. But the team had no idea what these things were. Then, in August 2024, the mystery only deepened. Using a remotely operated vehicle, they got a closer look at these formations. There were about 40 of them. No one had ever seen anything quite like this before in the Great Lakes. What could have created those craters? Could they be ancient? Perhaps remnants of some geological event lost to time? If that's the case, it's weird how long these holes have likely been sitting there, undisturbed. Theories started popping up. One possibility was that they could be sinkholes, or dolines. Those are basically holes that suddenly appear in the ground when the surface layer collapses. The rock beneath the surface, often made of limestone, gets slowly dissolved by water over time, creating voids underground. When the surface of those voids can no longer hold its own weight, it caves in, and this forms a hole. Think of it like when you poke a straw through the lid of a drink. Sinkholes can be small dips or huge, spanning up to 2,000 feet. They can happen gradually or all at once. Sometimes they can swallow entire cars or even buildings. And Lake Michigan sits on limestone bedrock. It erodes pretty easily when water flows through it. Sinkholes like these have already been found in Lake Huron, and they look kinda similar. But there are some plot holes, no pun intended, with this theory. For example, it's wild how they all would be so huge. It's also weird and pretty rare for sinkholes to occur in a lake bed. They also kinda resemble a straight pattern. They seem to extend generally southward, forming a loose line, which is pretty weird. If these are sinkholes, then they're definitely not playing the usual geological rules. Though it might be some new, unusual process at play beneath the lake's surface that we haven't discovered yet. There's another theory though. Glaciers. Glaciers are wild rivers of ice. They covered much of the Earth during the last ice age, and they're incredibly powerful. While they might move slowly, sometimes only a few inches per day, they have such immense weight that they can reshape entire landscapes over thousands of years. Glaciers can grind and scoop the land beneath them. They're basically like colossal bulldozers. Their weight, combined with the slow but steady movement, grounds down everything beneath them: rocks, soil, even bedrock. This can create deep gouges in the Earth's surface, called glacial troughs. During the last ice age, there were lots of glaciers all over the northern US, including the Great Lakes region. If they moved across what is now Lake Michigan, they could have carved out these deep holes. Glaciers often move in a pretty straight path. As they move, they cause terrain to erode, but the resulting erosion varies based on terrain. Sometimes there are places where the bedrock is softer or fractured, and these places are more easily carved and crushed by the glacier. That could explain why some holes could be bigger and deeper than others. Harder bedrock is less affected. But usually this leads to rounded, crescent-shaped depressions known as chatter marks. Those marks are more like grooves rather than circular, big craters like those in Lake Michigan. Once the glaciers melted, the Great Lakes themselves formed. If the craters were formed by them, they may have filled with water, becoming part of the Michigan Lake. Though this theory is more like a speculation, so we need more evidence. But there's another layer to this mystery. The craters are not just curious geological formations. They actually may hold valuable clues about early life on Earth. Parts of Lake Michigan, especially dark ones, are relatively low in oxygen. It's like a lighter version of deep ocean environments that often have very little of this element. For example, hydrothermal vents deep in the ocean, underwater openings in the Earth's crust with some hot, mineral-rich water that are often very low in oxygen. But some organisms love places like these. For example, opossum shrimp. Teeny tiny shrimp-like creatures that love cold, deep waters. They get their name because they have a pouch to carry their young until they're ready to be on their own, like an opossum. Or deep-water sculpin fish, small bottom-dwelling fish that also enjoys cold lakes.
They're well adapted to living in dark waters and usually stay close to the lakebed. And weird organisms like invasive quagga mussels, which kinda look like shells. These are small freshwater mussels that have spread there to the Great Lakes. They attach themselves to hard surfaces and can cause problems for ecosystems by competing with native species for food and space. All these guys could be in Lake Michigan, and even more. There might be microbes or even bacteria that are specially adapted to these harsh conditions, just like it was in Lake Huron. There's only a handful of creatures that could survive deep within these craters, and studying them could give us insight into how life once flourished in Earth's ancient, oxygen-poor oceans. That's because it's in places similar to these, where some of the earliest life forms thrived. Early Earth had an atmosphere with little oxygen, although it was much more hot and ancient microbes adapted to this. The Great Lakes, especially Lake Michigan, have always had a bit of a ghostly reputation. Like even this mission was organized to study the shipwrecks. There were about 6,000 of them in the Great Lakes. Many of these wrecks are still sitting on the lake beds, preserved by the cold, fresh waters. And shipwrecks aren't the only strange things tied to the Great Lakes. Over the years, there have been stories of unexplained disappearances. Boats and even planes have vanished without a trace. The lakes, often calm on the surface, can suddenly turn dangerous with unpredictable storms and massive waves, leading to these mysterious events. Not even mentioning all the creepy stuff people notice there over the centuries, such as ghostly lights above water or bizarre weather patterns like eerie, sudden fogs that seem to appear out of nowhere. In 2007, they even discovered some prehistoric structure that looks like Stonehenge there. Well, it was way smaller, but still. It lay about 40 feet below the surface in the heart of Grand Traverse Bay, and it's speculated to be about 9,000 years old, way older than Stonehenge. Looks like this is a print of those who lived in the area thousands of years ago. These massive stones are arranged in a careful, winding pattern stretching over a mile. They range in size from basketballs to compact cars. But one, in particular, stands out. A boulder 3.5 to 4 feet tall, 5 feet wide. It's etched with the image of a mastodon, a creature that roamed the Earth about 11,000 years ago before it went extinct. It probably sank there during the end of the last ice age we mentioned. This period had reshaped the region. This place is underwater now, but back in the day, it was still dry land. So the stones were probably created by people who lived there, though we're not sure why. Were they used as hunting blinds? Or was it some sort of an ancient calendar? Who knows? Only about 15% of the Great Lakes floors have been explored. Now, scientists are gearing up for a deeper dive into this mystery, both literally and figuratively. They want to analyze the lake beds surrounding the craters, hoping that maybe something in the environment around them might have caused them to appear. They have initiatives like Lakebed 2030. These missions should map the entire underwater landscape. This would help us learn tons of interesting stuff about Lake Michigan and our planet's past. Who knows what other secrets these dark waters hide?
If you pull up a map, here, let me do that for you. The Strait of Gibraltar looks almost laughably narrow. At its tightest point, Europe and Africa sit just about 9 miles apart. You could technically kayak that on a calm day, if only it wasn't highly dangerous. Now, engineers want to punch through rock, pressure, and moving continents to turn that ancient divide into a boring 30-minute commute. And it's going to take a lot of boring. Yeah, that's a joke. But wait, why go through all that trouble and not just connect Europe and Africa with a bridge? Well, the biggest problem is the Strait of Gibraltar itself. The water here moves fast. The currents rank among the strongest on the planet. Plus, the strait is exactly where the African and Eurasian tectonic plates meet. The African plate keeps creeping northward, slowly squeezing toward Europe. It moves ridiculously slowly, just a few inches a year. So no one is going to wake up tomorrow and stroll across. Scientists built a detailed 3D model of the region, and it shows that in about 20 years, the strait could finally close and turn into the Isthmus of Gibraltar, basically a land bridge between the continents. But why wait millions of years? Plus, right now, that slow plate movement still causes real-world trouble. When those massive slabs of rock grind against each other, they build a pressure. That pressure releases itself as earthquakes, tiny fractures, and sudden shifts in the ground under the sea. Nothing down there stays perfectly still. Even if someone managed to build a bridge, powerful streams could shake the structure non-stop and tear joints apart, unless designers created an insanely strong system. And that kind of engineering would eat unbelievable amounts of money and resources. If that's not enough, there's the depth problem. We're talking about almost 3,000 feet. That's one of the deepest straits on Earth. Any pile there would need insane length and strength, probably built from several massive sections bolted together. And even after installing them, earthquakes could still snap everything apart while currents drag pieces across the sea. But the most serious issue involves nature. The water here has a high salt content, which makes it heavier. That heavy salt water sinks into the Mediterranean basin and pushes colder water back toward the Atlantic. These movements create swirling currents, turbulence, and underwater boiling zones full of nutrients. That chaos feeds phytoplankton, tiny organisms that sit at the bottom of the entire marine food chain. Whales and fish absolutely love it there. The strange shapes of the seabed and the sunlight hitting different layers of water create perfect living conditions. If construction started, there would be dust, crushed rock, carbon dioxide, fuel, and falling materials. All of it would cloud the water and ruin the natural food chain. That's why a tunnel sounds like a better idea. Spain first proposed to build a modern tunnel here in 1930, but it was impossible to drill through hard rock with the technology they had at that time. But then, in December 2003, Spain, this time together with Morocco, decided to go back to the idea and build a tunnel that would connect the rail systems of the two countries. It took them another 20 years to start designing and planning the tunnel. Now, construction is scheduled to start in 2030 and will take around 10 years. This tunnel will need to be a true engineering marvel that will live with the motion of tectonic plates, not go against it. The structure will need flexibility, shock resistance, and a safety margin for movements that no one can perfectly predict. So, according to the new project, the tunnel would plunge down to more than 1,000 feet below sea level at its deepest point. That makes it about 6 times deeper than the Channel Tunnel between England and France. Now, length matters too. The full tunnel would stretch close to 25 miles, with roughly 17 miles directly beneath the seabed. Once you're in the middle, you're farther from open air than most people will ever be in their lives. It means no quick exits or easy rescues. Everything has to work perfectly. Ventilation, power, signaling, because there's no backup plan called just open a door. If it does work out, high-speed trains could carry passengers and freight from Spain to Morocco in about 30 minutes, something close to a regular subway ride. And that's not just convenience. That's a rewiring of trade routes, labor movement, tourism, and economic gravity between continents. More than 12 million people could travel on that route every year. Now, the design won't rely on one, but 2 parallel twin rail tunnels, one for each direction, plus service and emergency corridors in between. All of this will cost around $10 billion. And engineers will need to design something flexible enough to bend, absorb, and survive slow continental drift and constant pressure. The tunnel won't go against Earth. It will ride with it, like a shock absorber built into the planet itself. And this idea doesn't come out of nowhere, as humans have already built impressive underwater tunnels. The Channel Tunnel, the most famous example, already turned 30 in 2024. It runs under the English Channel, linking England and France. Trains can zoom through it in about 30 minutes, hitting around 99 miles an hour, and it's the longest underwater tunnel in the world as of now. 3 tunnels are running parallel under the seabed. 2 of them carry trains, one in each direction, and the third is a service tunnel in the middle used for maintenance access, evacuation, ventilation, and just general support. The whole thing was privately funded and crazy expensive. It went over budget, and while it eventually turned a profit, it hasn't been the financial goldmine people hoped for. Despite that, engineers still consider it one of the most impressive feats of modern civil engineering. And they even connected continents underwater before. Istanbul's Eurasia Tunnel has a 3.3-mile section that goes straight under the water. It links Europe and Asia by road in about 15 minutes. What once took nearly 2 hours now feels routine. The tunnel took 55 months to build and cost $1.3 billion. They had to reorganize traffic for it to make the access roads of the best quality. And the tunnel didn't just connect continents, but also help reduce atmospheric and acoustic pollution in the city. Right next to it, the Marmaray Rail Tunnel slides trains beneath the same strait, carrying commuters between continents like it's no big deal. These tunnels sit in an earthquake zone under shipping lanes, beneath constant currents, and they work. Once you see those projects, the Gibraltar Tunnel stops sounding insane and starts sounding possible, maybe even inevitable. Which naturally leads us to the most dangerous thought humans ever have. If we can do that, what else can we connect? Well, that's where the dream goes full sci-fi. People imagine stepping onto a train in New York and stepping off in London less than an hour later. No jet lag, no turbulence, just a straight shot beneath the Atlantic. Some proposals throw around numbers like 54 minutes, but that speed requires vacuum trains moving around 5,000 miles per hour. That technology doesn't exist outside of lab concepts and computer models, yet. Now, even if we ditch the sci-fi speed and use conventional rail, the trip would take roughly 15 hours, slower than an 8-hour flight. Then comes the real nightmare. The Atlantic is 12,000 feet deep on average, with pressure, geology, and distances that make Gibraltar look like a backyard project. Engineers would face earthquakes, underwater mountains, volcanic zones, and even finding a leak would feel impossible. Fixing it would be next level. The energy costs alone would make today's mega projects look cheap. That's why right now, a transatlantic tunnel lives in the same category as warp drives and cities on Mars. Inspiring, useful for pushing ideas forward, but not something you break ground on next year. The Gibraltar Tunnel, though, sits right on the edge of that line between impossible and inevitable. What once separated civilizations now tempts us as a corridor. What once seemed impossible now connects continents. Experts explain Africa is splitting in two, and it will look like this. Up close, the process is even more shocking, with a massive crack stretching from Mozambique in the south to the Red Sea in the north. This gap keeps growing every year, tearing apart the land and destroying homes. Now, specialists believe the continent could split much sooner than we expect. Africa is breaking apart because of the Somali Plate movement. Think of it like a dramatic breakup happening with tectonic plates. On the east side, there's the Somali Plate. On the west, we have the Nubian Plate. And during this breakup, the Somali Plate just wants more space, so it's pulling away from the Nubian Plate. This movement is forming the East African Rift, a region where tectonic plates are splitting apart, magma keeps rising from deep below, and a bunch of active volcanoes are being born. So this place is hot, with daytime temperatures that can soar to 130 degrees Fahrenheit, and at night they cool down to 95 degrees. Inside this hot zone, we have the Afar Triangle, also known as the Afar Depression, and its geology is fascinating, as the rifting process is causing valleys, faults, and deep cracks to form in this region. Take, for example, this massive 35-mile-long fissure in Ethiopia's desert. It's also so wide that a person can easily fit inside of it. But what's scary is this crack keeps getting bigger, growing about 1/2 inch every year. The Nubian and Somali plates moving apart could also lead to a new ocean forming in Africa. This type of process isn't something new. About 150 million years ago, when dinosaurs were still around, A similar tectonic shift created the Atlantic Ocean. The continents were once all clustered together, but when a rift formed in what was Pangaea, it started pulling them apart, splitting the east and west hemispheres. So, a similar thing is happening with this gap in Africa. At some point, experts say the waters of the Indian Ocean might flood the East African Rift Valley, eventually creating a sixth ocean. Now, it's a pity you won't be able to swim in its waters during your lifetime, though. According to geophysicist Ken McDonald, who specializes in tectonic faults, this dramatic rupture could happen in 1 to 5 million years. Trust me, that's considered fast in geologic terms, and way sooner than most experts thought. Now, even though you won't get to watch Africa breaking apart, people there will still see and feel the signs. They might experience intense volcanic eruptions and strong earthquakes as this process slowly unfolds. One example is related to that scary crack in Ethiopia's desert we mentioned earlier. The fissure was created in 2005, after the area was hit by 2 volcanic eruptions and 163 earthquakes, each with a magnitude greater than 3.9. A crack this deep and long on Earth usually takes centuries to form, but in this case, it unfolded in just a matter of days. That's how powerful this event is. In fact, this kind of intense seismic activity can speed up the African splitting process, and that's why it's so hard to predict the exact time frame for the event. What we know is that people are already calling this new land the Nubian continent. If the predictions are right, it will include Somalia, Kenya, Tanzania, and part of Ethiopia. That's exciting and concerning at the same time. As new coastlines emerge, countries will need to make major adjustments when it comes to infrastructure and land management. They might lose a lot of roads, houses, and other constructions currently located near or right in the East African Rift. In Kenya, for example, the fissures tore apart a busy road, and authorities desperately tried to fill the gap with rocks and cement. In another case, an old woman was sitting and eating with her family when her house suddenly split down the middle. Recently, earthquakes that happened near Ethiopia's Afar region demolished 37 schools and forced about 5,000 students to leave their classrooms. Unfortunately, stories like this could become more common over the next few years. But there is a positive side to all this. Countries located in the middle of Africa, like Zambia and Uganda, could gain coastlines, and that might be great for them. Having a coast means they would get access to new trade routes, opening fresh economic opportunities. Plus, think about the tourism boom. With all those newly formed paradisical beaches, these countries could become the next big gateway spot for travelers. The local ecosystem in this newly created ocean will change as well, and new marine species may emerge. So, let's look. This is the path where the rift is most advanced right now. I mean, we expect this is where Africa will eventually get separated. But things could get a little more complicated. Some time ago, Michael Daly, a geologist at the University of Oxford, suggested that this rift could extend further west. And some new evidence backs up his theory, pointing out that the crack could extend south through Botswana's heartland into South Africa, and west through Namibia, all the way to the Atlantic Ocean. If these fractures widened into deep cracks, the ocean might come in and fill the gaps. Experts say Africa could split so much that it becomes an archipelago. But then again, we won't see that happening. It will take tens of millions of years for this to play out. We already know that Africa is at risk of breaking into a bunch of huge islands or small continents. The news isn't great for Madagascar either, as the world's 4th largest island could end up being split in half. But can the opposite process happen? I mean, can new land appear as the Nubian and Somali plates move apart? Well, as these tectonic plates get away from each other, the magma from the Earth's mantle might rise to the surface, and when it cools, it solidifies into new land. That's how other places in the world emerged, like Iceland and the Azores. So, yeah, the same process could happen in the East African Rift, and over the long term, it is possible that the rift could create new islands. For now, all we can say is that the geology of the Afar Depression is unique. It is the most active rift system on our planet. And when I say rift system, I mean a zone where tectonic plates are pulling apart. This region brings together all kinds of events, from faults in the Earth's crust to volcanic zones to the potential formation of a sixth ocean. For experts, it's like studying the evolution of rifts up close. And since it is such an active volcanic area, it also has enormous potential for tapping into geothermal energy, that is, using heat from inside the Earth to generate electricity. 2 geothermal power plants are already producing energy in Ethiopia, one in the Ethiopian Rift Valley and the other in the Afar. Now, geologists are exploring new potential spots. When we look at that deep crack in the ground, we know it's caused by tectonic plate movement. There's no mystery there. But what we still don't fully understand is why the cracks happen exactly where they do. For example, a crack that opened up in Botswana appeared after a magnitude 6.5 earthquake back in 2017. But the epicenter wasn't in the rift zone, where the plates are moving like we would expect. Instead, it was farther south. Since it's unusual for a rift to happen without volcanic activity, this fact really challenges our traditional ideas of how continents divide. Figuring out why these cracks appear in specific spots is still a missing piece of the puzzle for experts trying to explain how Africa is splitting. Hopefully, we get some answers before the continent turns into a massive archipelago. It's been there for over 3 billion years, but now some of the Earth's oldest crust is falling apart. Today, our continents seem stuck in place, but over a long time, they've moved and shifted around a lot. It's all thanks to tectonic activity, which makes part of Earth's surface slowly slide around like pieces of a giant puzzle. Some of the most stable parts of these puzzle pieces are called cratons. Cratons are super old and strong sections of rock that form the roots of continents and keep them together. The North American craton is one of them. It makes up a big part of the United States, about half of Canada, and most of Greenland. Scientists have singled out about 35 of these big ancient cratons around the world. They've mostly stayed in the same place for hundreds of millions of years because of how strong they are. But in 2014, they discovered that cratons might not be as indestructible as they thought. Some cratons had lost parts of their strong roots because of certain geologic processes and became thinner. It looks like cratons could become less stable if they go through more tectonic changes. In 2024, scientists at China University of Geosciences analyzed an ancient landmass called the North China Craton, or NCC for short. They wanted to learn more about how some of Earth's oldest rock regions can break apart. This process of cratons disintegrating is called decratonization. The NCC is so interesting to study because it has 3 main parts: the Western Bloc, the Eastern Bloc, and the Trans-North China Orogen, a zone that lies between the 2 blocks. Scientists found that during the Mesozoic era, the Eastern Bloc lost its deep ancient roots because of the strong Earth movements called tectonomagmatic events. So scientists wanted to see exactly how the processes in the mantle and the movements of Earth's plates led to the breaking down of the NCC. They created 4D models showing how the NCC's shape changed over time, including its surface shape, how its layers stretched, and the way earthquake waves moved through it. They found that a section of the tectonic plate slid beneath the craton and then began to roll back. This rolling and stretching made the strong rock thin out and eventually lose stability. All this started around 200 million years ago, back during the Jurassic period, when dinosaurs were rocking the world. The North China Craton isn't the only place where this decratonization process can happen. Other cratons, like those in North America, South America, and China's Yangtze region, may have gone through similar changes. Scientists say this shows how the continents on Earth have slowly changed and evolved over billions of years. And it looks like, when it comes to geology, there's no place that is 100% safe from changes, but it's no cause for alarm. You don't notice this, but our planet never stops moving and is perfectly normal. But sometimes, this movement still brings dramatic changes. In 2017, scientists made an official announcement that Zealandia can be called a new continent. The continental shelves of this mysterious continent are lying at a depth of around 3,280 feet below sea level. The nearest oceanic crust dives even deeper, at 9,800 feet below that. Geologists have gone deep down to collect rocks from the ocean floor. They have found that, unlike the nearby oceanic crust, which is made up of fresh basaltic rocks, the crust around New Zealand is a mix of ancient granite, limestone, and sandstone. All this screams continental crust. Plus, scientists have discovered a narrow strip of oceanic crust that separates Australia from the hidden land of Zealandia. It means these two are separate continents. 85 million years ago, Zealandia decided to break free from the supercontinent Gondwana. Millions of years later, the mighty Pacific Plate, the heavyweight champion of tectonic plates, decided to take a dive beneath Zealandia's continental crust. And that's how the root of Zealandia, that connection to its continental crust, broke off and went into the depths below. And that's not all the tectonic news from this part of the world. 120 million years ago, Australia and Antarctica were a single piece of land. They went their separate ways, but Antarctica didn't leave empty-handed. Today, there's an oceanic plateau in the Indian Ocean. Long ago, it was connected to another lost continent, the Kerguelen microcontinent. Scientists believe that it made a land bridge between India and Antarctica. To find out what it was like, we can look at a tiny archipelago in the southern Indian Ocean. These islands are all that is left of the ancient landmass. They have a cold climate and feature glaciers because they're so close to Antarctica. But in the past, the weather here must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that live in tropical regions today. Another lost and found continent isn't hiding in the ocean, but under Europe. It's called Greater Adria, and it collided with Europe and started to sink under it around 100 million years ago. Today it lies beneath Italy, Greece, and the Balkans. Its size and even shape match that of Greenland, the world's largest island. Greater Adria is no longer visible, but it left some clues. Part of it was embedded in the Alps. The other chunks are part of present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Great heat and pressure spread over tens of millions of years changed their structure. And that's when the limestone left the chat and the marble took its place. Greater Adria wasn't a solid piece of land like the big continent we see today, but more like a giant shallow shelf underwater. Over time, sand, mud, and other stuff settled on this shelf and slowly turned into rock. Greater Adria might have been a little like Zealandia or the Florida Keys, a chain of small islands sitting in a shallow sea. Above the water, there were probably lots of little islands and archipelagos, and beneath the waves, there were colorful coral reefs filled with marine life. If you lived back then and had a scuba tank, it would have been an amazing place to dive and explore. So, with all the things going on with the Cratons, who knows? We could see a new continent in the future. Plus, studying the Earth's crust even deeper can change history as we know it. Scientists in Copenhagen have made an amazing discovery about the real birthplace of Scandinavia, and it's not where we thought. After studying sand and rock from remote parts of Finland, they found out that Scandinavia's roots actually came from Greenland over 3.75 billion years ago. This means the area where Nordic countries are now is 250 million years older than the scientists had previously believed. And we now know, thanks to the tiny crystals called zircons found in Finnish river sands. When scientists looked closely at their chemical makeup, they realized the age of crystals matched the rocks found in Greenland, not Scandinavia. They used special techniques to analyze elements like uranium, lead, lutetium, and hafnium, and discovered that Scandinavia's rocky base most likely broke off from Greenland billions of years ago. A small seed of land probably started drifting across the Earth's surface over hundreds of millions of years. This piece eventually settled where Finland is today. Over time, new layers of rock formed around this seed and slowly turned into the Scandinavia we see on maps now. The same study could help us rethink how the continents on Earth first formed. The most accepted theory is that the continental crust began growing right when the planet was formed. But new studies show that the signs of continents only started growing a billion years later. The scientists explain that Earth's continents may have begun as tiny seeds of ancient crust in different places. These seeds grew over time, forming the landmasses we know today. These ancient seeds aren't just found in Scandinavia, but also in Australia, South Africa, and India. Scientists aren't sure if all these seeds came from the same place or if they grew separately in different parts of the world. So there's still a lot to learn, and scientists need to keep digging to figure out if all these ancient seeds are related to each other. Now, at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot, even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore. But when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangaea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangaea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangaea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo-Pangaea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novo-Pangaea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangaea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat. Surprise! There's more than 7 continents on our planet. Argoland, a hidden continent, may help us understand how our planet will look in the future. To find out how it hid from us and what secrets it holds, well, you'll just have to keep watching. Ready for a mystery? Scientists have been looking for a piece of land that's been missing for over 100 million years. Not exactly newsworthy, since people search for information about our planet's history all the time. You'd think it was probably this minuscule island somewhere in the middle of an ocean. Well, you'd be wrong, because this continent used to be as big as the entire U.S. territory. For a long time, geologists have been wondering whether a massive chunk of contemporary Australia vanished into thin air. Some believed it was simply hiding somewhere on the ocean floor. But thanks to some Dutch specialists and 7 years of investigating, we now know there are bits and pieces of this lost land mixed underneath the lush jungles of Southeast Asia. The continents we see in our geography manuals these days are like scattered pieces of a puzzle. There's even a nice experiment you can conduct to see for yourself. Find a world map online and print it out. Cut out all of the continents and play around with them for a while. You'll see they all fit together. Probably the most striking thing you'll see is how South America perfectly fits near Africa. If you close up the oceans that were formed in the last 200 million years, the continents look like they form a giant letter C. And that C is what scientists call the supercontinent Pangaea. It was swimming in an ocean called Panthalassa, and the inner portion of that letter C had a smaller stretch of water called the Tethys Ocean. It is in this small ocean where things get interesting. Back in the Jurassic period, this vanished continent, which scientists started calling Argoland, vanished and left a hole in Australia, now known as the Argo-Abyssal Plain. Geologists initially believed this was all due to a process called subduction. It's when one piece of the Earth's crust dives under another and recycles it into the planet's mantle. Usually, specialists track this continental vanishing through off-scraping. That's how they figured out, for instance, that India bumped into Asia and gave us the majestic Himalayan mountains. But for Argoland, things were a bit more complicated. Bits and pieces were popping up in places like Myanmar and Indonesia, but they behaved like these time-traveling relics, looking way older than when Argoland supposedly separated from Australia. It immediately raised the question: if one continent can behave so weirdly, how many others are out there doing the same? Thankfully, scientists have now put together the entire timeline of Argoland and figured out its mystery. It didn't sink or get swallowed up. It simply transformed into an archipelago, breaking into smaller pieces, called microcontinents, and floating away from Australia. These mini-continents then took a little journey before settling down in Southeast Asian jungles. This discovery fits right into the whole Pangaea puzzle. It helps us better understand how continents break up and make up, all in one discovery, revealing secrets of biodiversity and climate back from in the day. If you'd like to find out more secrets about history, civilization, or random day-to-day objects, be sure to like this video and subscribe to the channel. Like, for instance, the mystery behind this invisible species line in Indonesia. It's called the Wallace Line, named after the British explorer Alfred Russel Wallace. Over 150 years ago, Wallace was on a journey around the Malay archipelago, visiting thousands of islands. What he found was that animals on one side of this invisible line were considerably different from ones on the other side. This invisible line is like a wall between marsupials and tigers, for instance, or honey-eaters and trogons. But now we know that around 35 million years ago, Australia broke up with Antarctica and collided with Asia, and this continental love triangle triggered significant changes. It didn't just change the way the land looked, it also messed with the species of animals on each side of the Wallace Line. In more recent times, a bunch of specialists published a study saying this collision and climate chaos made Asian species comfy living in the Malay archipelago. Meanwhile, the Aussie animals weren't as happy with the new environment. It was too hot and wet for some, and others just couldn't handle the tropical island lifestyle. The discovery of this continental shift towards Asia might also explain a recent finding of a human species that didn't seem to make any sense either. You see, in this hidden cave in the Philippines, archaeologists stumbled upon a new human ancestor. It seems that about 50,000 years ago, on the island of Luzon, there was this ancient human-like species. The lead researcher believed this finding was crucial for understanding human evolution in Asia, and it named this new species after the island, Homo luzonensis. Now, here's where it gets a bit confusing. The bones found by archaeologists had one small problem. They had a weird mix of traits that hadn't been seen together in any other hominid species. Smaller teeth, similar to ours, yet hands and feet that were more like our ancient humanoid ancestors. It was those throwback limbs in particular that connected this human species with the long-lost Southern Territory. That's because they have this primitive look, like these hard-to-pronounce guys, for instance. Only these two species are separated by 2 to 3 million years of time in evolution. Many have wondered, is Homo luzonensis really a new species? Not everyone is convinced. But it may also explain why living creatures are also affected by the constant shifting of the land underneath us. Now, just because they haven't changed much during our lifetime, it doesn't mean our continents will look like this forever. They evolved from this large megacontinent, and they'll most likely end up in a similar position in the future. On that note, a geologist from a European university tried to predict the future of Earth's supercontinents. As a starting point, he used an earthquake that occurred in Portugal back in 1755, when tectonic plates behaved a bit differently than they should have. After years of research, he came up with a theory in 2016. He believed that the stitches between these tectonic plates might be coming apart, setting the stage for a bigger rupture. It's like when glass cracks between two holes in a car windshield. If this happens, a subduction zone could stretch from the Mediterranean all the way up past Ireland, bringing volcanoes, earthquakes, and new mountains to these areas. If all goes according to this plan, the Atlantic Ocean will disappear, and so will the Pacific, turning into one large stretch of water. Instead of the 7 continents we know today, we'll get a new supercontinent, which he called Arica, because it would have Australia and the Americas at its heart. Now, it's not the only possible scenario, though. Novo Pangea might be another, and it's easy to foresee. The Atlantic stays open and the Pacific closes. Then there's Amasia. For this one, you'd have to imagine the Arctic Ocean closing and the Atlantic and Pacific staying open. Everything shifts to the north around the North Pole, except Antarctica. One final scenario would be called Pangea Ultima. Slow down the spreading in the Atlantic, and a new subduction plate pops up on the America's east coast. Well, either way, if all the continents collide in the future once more, some say it won't be fun to experience. It's believed that in around 250 million years, we'll feel like we're being trapped in a sweltering, soggy plastic bag. Weirdly, that bag will be the best place to live on Earth, the coastal areas. As for the inland spots, they'll be sizzling, like a desert on fire. Many of the species of animals we know today might not make it. As for us humans, we'll need to be creative if we want to withstand the heat. We should be thankful, though. These digital models are still great because we can use them to test all sorts of interesting ideas. For example, how these supercontinents would mess with tides. Taking future space travels into consideration, these models can help us understand the climates of exoplanets too. Those are located outside our solar system. Do you know how many continents there are on Earth? That's an easy one, 7. But wait a second, aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist, or at least they used to. They are hiding under other land masses. Peekaboo! Researchers have recently discovered one continent just like that. It's called Greater Adria. Sound familiar? Yes, it has something to do with the Adriatic Sea. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's eighth continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint – under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low, and that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, and there would still be 7,000 feet between it and sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other, one goes down while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Yep, the coldest and one of the hottest places on Earth were once the same territory. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean. These islands are all that is left of an ancient landmass. They have a cold climate. The islands feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The lost continent's landscape probably resembled that of New Zealand. Now, while we're in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right of the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. But there is evidence of an even greater landmass, the lost continent of Mauritius. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steps of Mauritius. They found a mineral that exists in rocks which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. The local dishes would definitely be spicy. Now, speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Saul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side and the Greater Australia on the other. Back then, Bali stood at the southernmost tip of Asia. Biologists were among the first scientists to notice the split. Species developed differently on Sunda and Sahul. That's why Australia has unique animals, such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. Today, the two islands are separated by the Torres Strait, but it's quite shallow, less than 65 feet. It's a reminder that this was once a single landmass called Saul. Another ocean strait that isn't too deep separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels were 300 feet lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Talk about the ultimate backpacking route. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangaea was a supercontinent that included all of the continents. Its name is in Greek, and it simply means all Earth. But Pangaea started to crack up. The biggest gap formed between the Americas on one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 1 inch per year. Doesn't seem much when compared to the average human lifespan, but in the end, all the continents will reconnect with each other, forming a supercontinent. And it wouldn't be the first time in Earth history that this happens. Honestly, I'm not going to wait around for that. Hey, quick question. How many continents are there? 7? Maybe 5? There's no correct answer. According to different approaches, the range is between 4 to 7. But it might actually be as many as 8. Chances are, a lost continent has recently been found between Greenland and Canada. This new continent discovery could also potentially be the key to how microcontinents form. What does this all mean, and what makes this hidden landmass near Greenland so important? Now, if you're like me, and if you are, then there's 2 of us, when you hear the word continent, you probably think of land like Europe or Africa, places above water where people live. But in science, a continent isn't about being above sea level. It's about what the land is made of. Earth's outer layer, called the crust, comes in 2 main types, continental and oceanic. Continental one is thicker, lighter, and made of different types of rock, like granite. The oceanic crust is thinner, heavier, and made mostly of dark volcanic rock. Now, the discovery under the Davis Strait between Greenland and Canada appears to be a piece of continental landmass, even though it's under the ocean. Scientists call it a proto-microcontinent because it began to break off from a larger terrain millions of years ago, but never quite made it. As tectonic plates slowly shifted, the Earth's crust in this region stretched and cracked. One chunk started to split away, but for some reason, the process stopped. It didn't drift off like a full continent, and it didn't sink like ocean crust either. Instead, it stayed right there, floating beneath the waves all this time. This makes it different from true microcontinents, like Zealandia, which have completely detached and now exist as separate tectonic blocks. Zealandia is a submerged microcontinent near New Zealand. About 94% of it lies underwater, but because it's made of continental crust, many geologists say it qualifies as Earth's 8th continent. However, Zealandia is still debated because it's too big to be a microcontinent and there's no official global body to define its status. There's no global organization like the UN or some kind of international geology council that can declare, hey, this is a new continent. Unlike Madagascar, which is fully above sea level and widely accepted by geologists as a classic example of a microcontinent, Zealandia is still waiting for a proper label. I know you're probably wondering, isn't Madagascar an island? The simple answer is, it's both. It's the fourth largest island in the world completely surrounded by water, but it's also geologically considered a microcontinent because it broke off from the supercontinent Gondwana around 88 million years ago and is made of continental crust, not oceanic crust. Unlike volcanic islands like Hawaii, this isn't just built from lava. It's a real piece of ancient continental crust. So, Madagascar checks both boxes: island by geography, microcontinent by geology. And that's exactly why these discoveries can be fascinating. Just like Madagascar stands out above the waves, this newly discovered landmass under the Davis Strait stands out beneath them, thanks to its unusual structure. What makes it stand out is its unusual thickness. Most of the ocean floor is thin, like metal. This is more like packed clay, layered with continental materials. Underneath this cozy comforter, scientists discovered some odd layers of rock, unusual because they're not where they should be. These layers act more like the materials found on continents rather than those typically seen on ocean floors. There are hints of granite-like formations and distinct magnetic properties, which suggest that this stuff is similar to what makes up dry land. The size is also remarkable. The proto-microcontinent is about 12 to 15 miles across, which makes it roughly the size of a mid-sized city, like Manhattan Island that's 6,500 feet underwater. The fact that it sits right under the Davis Strait, one of the widest ocean passages on Earth, makes it one of the largest submerged continental fragments we've found. According to researchers, this landmass began to form between 58 and 49 million years ago, when Greenland and Canada were slowly drifting apart. Maybe they just weren't getting along. Hey, it happens. As they pulled apart, the crust under the Davis Strait stretched, and one of the main fault lines shifted. But the breakup didn't finish. Around 48 million years ago, the rifting stalled and Greenland's motion away from Canada slowed dramatically when it later bumped into Ellesmere Island. It's like a car swerving off and then back onto the freeway, a turn that was never completed. That's basically what happened. A chunk of land got stuck between the motion. It didn't float off into the ocean like a new continent, and it didn't get pulled down into the earth either. It just stayed where it was, stranded beneath the water. But that's not all. This chunk has its own fault system, and scientists say it actually looks like a miniature version of the San Andreas Fault in California. Now, a fault is basically a crack in the Earth's crust where sections of rock slide past each other. Think of it as a place where the Earth's surface split and tried to slide sideways. In California, this movement still happens today and can cause earthquakes. But under the Davis Strait, it's a different story. The movement started, then suddenly stopped, like hitting pause in the middle of a big shift. It's a frozen moment in the planet's past, preserved right beneath the waves. For geologists, that makes the microcontinent under Davis Strait incredibly valuable. That sudden pause in motion helps explain why some chunks of land break away cleanly while others twist, stall, or disappear. But this isn't just academic. By studying how continents break apart or stall, scientists can better predict future shifts in land, fault lines, and seismic activity. And predicting earthquakes and geological hazards could prove quite valuable to everyone. Knowing how microcontinents form could help us anticipate how the planet's surface might shift over millions of years, which affects everything from climate models to resource availability. But even just the technological advancement needed for such discoveries is greatly beneficial. The same tools used to map this hidden land are used for oil exploration, laying undersea cables, climate monitoring, and even search and rescue missions. Speaking of technology, for a long time, this hidden landmass near Greenland remained invisible. Just 10 or 15 years ago, the ocean floor under the Davis Strait was basically a mystery. It's deep, almost frozen, obviously not the easiest place to explore. But today, thanks to modern tools, a new continent discovery could be just a matter of time. Scientists can finally see and hear what's going on under all that water. First, they use seismic reflection imaging. That's a method where ships send sound waves down to the ocean floor and record how they bounce back. Various layers of rock reflect sounds in different ways, which helps build a picture of what's hidden underneath. It's kind of like how bats use echoes to see in the dark. Satellites also play a role in collecting gravity data. This may sound strange, but different types of rocks have slightly different weights. Heavier rocks create stronger gravitational pull, and satellites can measure those tiny differences. Another tool commonly used for these explorations is underwater sensors, which sit quietly on the seafloor and listen for natural vibrations, like mini earthquakes or shifts in rock. These vibrations help scientists figure out what the crust is made of and how thick it is. They're basically ears on the ocean floor. They also most likely used AUVs, or autonomous underwater vehicles, basically robot submarines that can scan the seafloor in high resolution, even under thick ice. In any case, scientists are very excited because this new continent discovery is more than just a geological surprise. It's what they call a natural laboratory. The study of the microcontinent Davis Strait offers a rare opportunity to understand how microcontinents form, evolve, and sometimes fail to fully separate. It also reminds us that Earth's crust isn't as neatly divided as we once thought. Beneath the ocean, there may be other hidden landmasses near Greenland or elsewhere, almost continents just waiting to be found. This lost continent of Canada may not have made it as a fully fledged landmass, but its discovery is already reshaping how we view plate tectonics. And thanks to advances in technology, places we once ignored are now offering up secrets about the planet's deep past, and maybe even its future. Okay, Smarty Pants, answer this one. Do you know what earthquake magnitudes actually feel like? Well, at magnitude 1, you wouldn't notice a thing. At 3, you might slosh your coffee if you're drinking. At 5, things can start to shake off shelves, and it definitely gets your heart racing. But at 7.5, that's when the ground itself rips, buildings sway, and whole streets can split. And now, scientists warn a fault we thought wasn't active anymore could unleash something that strong under a small sleepy town in Canada. Now, if you trace your finger across a map of northwestern Canada, you'll find Dawson City in the Yukon. It looks like a nice place to escape from civilization. After all, it only has about 1,600 residents. It's quiet, remote, and famous for its gold rush past. In the late 1890s, Dawson City ballooned into a boomtown almost overnight as prospectors chased gold. Today, the rush is long gone, but the town still looks the part. Wooden boardwalks and saloon-style facades give it the feel of a set straight out of a Western movie. Oh, and beneath all of that is a fracture in the Earth itself. Dawson City is located on top of what's known as the Tintina Fault. It's a massive crack in the Earth's crust that stretches for hundreds of miles toward Alaska. Until recently, scientists believed that this zone had been inactive for over 40 million years. But newer studies tell a different story. Just a quick reminder, faults are giant cracks when two slabs of Earth's crust meet. They're always trying to slide past each other, but their jagged edges catch and lock. Pressure builds for decades, continuously bending and straining the rock. Then, suddenly, the locked zone breaks, and the slabs slip into a new position in just seconds. That abrupt lurch releases all the stored energy, sending seismic waves racing outward. The ground-shaking consequence is called an earthquake. Scientists say the ground on each side of Tintina has been trying to slide past itself for ages, but it's stuck. And now, that stuck zone has built up around 20 feet of strain. That's how far the land would shift sideways if it all gave at once. That's not just a small crack. That's straight up something from a disaster movie. If all that built-up tension snaps in one go, the result could be a magnitude 7.5 earthquake. How strong is that? Well, pretty strong. So, what happens during a big quake? The shaking can last up to 30 seconds or more. which is an eternity when the walls are swaying and the floor feels like it's rolling under your feet. If you're near the fault, things can get really scary. The ground doesn't just shake, it could take a big step sideways. This can lead to some renovations. Roads might get a new zigzag pattern, and unreinforced buildings could decide to do the twist. And if it happens in a Canadian winter, let's just say it could turn a simple power outage into a survival horror adventure. Being on soft soil is like sitting on wobbly jelly. It amplifies the shaking. Solid rock is a bit more stable. However, it's still dangerous. For example, in Mexico in 2003, a 7.5 quake damaged over 43,000 homes, buckled roads, and cut power for miles. In Sulawesi in 2018, the same magnitude not only leveled buildings, but triggered a tsunami and liquefaction. The whole neighborhood was swallowed as the ground turned to quicksand. Now here's something interesting. Most people don't think of Canada as an earthquake country, but it actually gets around 5,000 quakes a year. However, they're so small that you'd never feel them. The real hot spot is the West Coast, near British Columbia. That's where you hear people whisper about the infamous Big One. It refers to a future megathrust earthquake along the Cascadia subduction zone, a massive fault that runs for 600 miles just offshore. Unlike Tintina's sideways slip, Cascadia works by one tectonic plate shoving under another. For centuries, the North American plate has been bent upward like a spring as the Juan de Fuca plate has been diving below. When it finally snaps, that's a magnitude 9.0, more than 30 times stronger than a 7.5. We know it can happen because it already has. The last big one struck in 1700. It was so powerful, it didn't just shake the Pacific Northwest. It launched a tsunami across the ocean that smacked Japan, where villagers recorded an orphan wave with no local quake to explain it. Only later did scientists connect the dots. Now this brings us to the fact that despite all this, the size of the fault, the quiet buildup of strain, and the potential for a magnitude 7.5 earthquake, the Titina Fault isn't even listed on Canada's official seismic hazard map, at least for now. That means no warnings, no color-coded danger zones. And when a fault isn't on the map, nobody designs a building for it. There's no proper preparation. You don't build reinforced structures or have seismic codes, especially when people don't expect that the ground could split open. Now, to be honest, that's not someone's mistake. The fault just didn't show any signs of being active recently. And this part of Canada is really big, quiet, and doesn't have a lot of monitoring. Not until too long ago, people had thought of the Titina as just a geological oddity, something cool for looking at the past, but not really relevant for the future. For years, the Titina Fault flew under the radar, but that changed when researchers brought high-tech gear. They uncovered subtle but clear land shifts near Dawson City. They looked like scars on the landscape and pointed to past earthquakes, including one that pushed the land nearly 3,000 feet over millions of years. Now, interestingly, newer glacial features showed no signs of disruption, which means the last major quake probably happened right before the end of the last ice age. In geologic terms, that's pretty recent. When scientists lined up those land shifts with the ages of glaciers, the picture was clear. The Titina Fault isn't retired. It's just been on a really long coffee break, and now it's itching to clock back in. That's why researchers want it officially on Canada's seismic hazard map. Dawson City deserves more than a shrug emoji when the ground decides to stretch. The experts are basically playing detective with dirt. They're scanning forests and rivers for faint scars that past earthquakes tried to hide. They're digging trenches like archaeologists with a taste for chaos, flipping through the Earth's diary one muddy page at a time. Every crack, wrinkle, and layer adds to the story of when Titina last threw a tantrum and how loud the next one could be. It's pretty cool that satellites can literally track if one side of a valley is slowly creeping ahead of the other, like tectonic snail racing. The goal is to find out how often this fault snapped in the past, how much stress it's still holding on to today, and whether it's going to go off quietly or all at once. Finally, just because you know that plates are pushing against each other underneath, you still can't put a date on it. Long stretches of silence might mean the rocks are getting ready for something huge, or they could just be releasing stress in tiny ways that go unnoticed. Scientists can model possibilities, but no one has a countdown clock for the next rupture. The smartest mindset isn't prediction, it's preparation. You brace for the plausible, not the precise, because the Earth's schedule doesn't come with reminders. It turns out the Earth's crust is always fidgeting. It's just that our maps are a little behind on the gossip. A fault everyone thought was harmless might actually be sitting on a magnitude 7.5 size secret. But don't worry, this isn't a cue to panic. It's a cue to get smart. Better data, sturdier buildings, and a few just-in-case habits. When the ground finally decides to settle its debt, what really matters isn't whether Dawson City feels the shake. It's whether everyone's prepared enough to turn a potential disaster into just a real wild story to tell later. Hey, have you ever been in an earthquake? I have. Tell me your story in the comments.
Canada is massive, but almost everyone lives in the east or the west. And right in the middle, there is this huge stretch of land where hardly anyone calls home – Northern Ontario. So why does this place almost feel off-limits? Northern Ontario is part of, well, Ontario. It's a super busy province, home to major cities like Toronto and Ottawa. About 1/3 of all Canadians live there, but most of them are down in the southern part of the province, not up north. But that doesn't really add up when you think about it because the northern part is way, way bigger. We're talking about a region that is more than 300,000 square miles, pretty much the same size as the whole country of Turkey. Northern Ontario takes up about 87% of the entire province. But, strangely, only about 6% of Ontario's population lives in this area. But before you start dreaming about moving there for some peace and quiet, hold on. There are 4 big reasons people choose not to, and honestly, you'll probably agree. Reason number 1. The land itself. Look up the region on Google Earth, and all you will see is a huge stretch of empty space. Nothing special at first glance. But zoom in, and that's when things start getting complicated. Northern Ontario is famous for its rugged, remote landscapes, full of endless forests and lakes. It's beautiful to look at or snap a photo of, but living there is a whole different story. The geography makes the area tough to get around and makes it hard to build things like transportation routes and railways. And since it's so difficult to put decent roads up there, the whole region stays pretty isolated. That takes us to reason number 2, remoteness. You might think that, being in the center of the country, it could serve as a great link between the eastern and western parts of Canada. But in reality, that's not how it works, and the region is very far from Canada's major cities. Take Greater Sudbury, the largest city in Northern Ontario, with around 160,000 people. The closest major city is Toronto, which is about 230 miles away. So yeah, that's roughly a 4-hour drive just to get there. If you're planning a holiday weekend in a big, dynamic city, a 4-hour drive sounds like a fun road trip. But if you need to go for a dental appointment or sort out paperwork, that distance suddenly feels endless, not to mention the cost. Unfortunately, that's how life is for many people up there. Residents of Northern Ontario don't have easy access to opportunities or services. With so few people scattered across such a huge area, the region doesn't have enough facilities, infrastructure, or easy access to essential services like healthcare and education. People there sometimes have to deal with poor or even non-existent infrastructure, like missing roads, airports, hospitals, and schools. Without those things, settling down is really tough. And in rural areas, it's even worse, because the lack of services can seriously hurt their quality of life. Psychologically speaking, that's not great either. People can end up feeling isolated and lonely, and the freezing weather doesn't help. Which brings us to reason number 3 why most people don't live in Northern Ontario: the harsh climate. If you're not a fan of cold weather, you should definitely leave this region off your travel bucket list. Winters up there can be long and brutal, with temperatures sometimes dropping as low as 40 degrees below 0 Fahrenheit. Have you ever tried shoveling snow when it's this cold? Yeah, it's not exactly fun. That kind of harsh weather doesn't just mess up your weekend plans or your daily jog, it also makes transportation a huge challenge. The result is that many residents end up isolated from essential services and job opportunities. And it's also really hard to build infrastructure, grow industries, or run businesses because of that harsh climate. Take farming, for example. Compared to southern Ontario, the northern region has a shorter growing season and much colder weather. Although crops like oats, potatoes, and green beans can handle the cold, the climate usually limits the variety of things that can be grown. That's why most farms are concentrated in the southern part of the province, and in other parts of the country, like the prairies and Quebec. Anyway, that's just one example of how the climate makes it tough for people to build a strong foundation to support themselves. And that's exactly the fourth reason why Northern Ontario is so empty: the economy. It's not that there aren't any jobs available. In fact, there are plenty. In 2023, the northern part of Ontario had some of the highest job vacancy rates in the country. So unlike in many parts of the world, it's a place where they have tons of jobs available, but no people to fill them. One reason people don't take those jobs is that many of them are older. Just look at Elliott Lake, for example. 42% of the people living in the city are over 65 years old. That's the third highest concentration of older adults anywhere in Canada. But it's not all that different in the rest of the region either. Estimates show that by 2036, people aged 65 and older will make up almost 30% of Northern Ontario's total population. And do you see what happens when they hit 65, right? They've got their pensions, and going back to work just isn't on the radar. This problem only gets worse because young people just don't seem interested in living there. Every year, lots of students around 17 or 18 years old pack their bags and either drive across the province or fly across the country to study somewhere away from their northern homes. And many of them don't come back. But that's actually pretty strange considering the region does have a strong economy, especially in mining. Take the Red Lake area, for example. It's packed with gold. In fact, it's home to one of the richest gold deposits in the world and has already turned out over 30 million ounces of the metal. That's definitely helped Canada stay ranked among the top 5 gold-producing countries in the world. Then, there's this region, known as the Ring of Fire. It's centered around McFalds Lake in the Kenora district and covers about 1,900 square miles. It's rich in valuable minerals like chromite, cobalt, nickel, copper, and platinum. These days, Northern Ontario's mining industry is making a big comeback and attracting new investments. That's happening because the world is suddenly desperately looking for critical minerals. By that, I mean essential elements used in modern technologies like smartphones and renewable energy systems. Minerals like cobalt, nickel, and copper are especially important for making the batteries that power electric cars, for example. So, right now, it seems like the whole mining scene in the region is doing pretty well, but the industry has gone through plenty of ups and downs, with fluctuations and periods of decline. And that, combined with the possible lack of variety and jobs outside the mining industry, means people are more likely to leave the region in search of better opportunities. Interestingly though, mining companies are now struggling to find enough skilled workers in Northern Ontario. And that's probably because of all the reasons we've already talked about: an older population, harsh weather, tough geography, and a long distance from major urban centers. So, it's basically a cycle. And local authorities are trying to break out of it by improving infrastructure in the region, offering more incentives, and finding ways to keep young workers from leaving. Some of their strategies include offering cash rewards to people who refer healthcare workers for job openings or providing tax-free payments to help cover higher home energy costs. And there are plenty of other initiatives too. So yeah, with strategies like these, it's definitely possible to grow the population there. And who knows, maybe one day this region could be bustling with people.
Imagine standing in a quiet northern town, surrounded by mountains and forests, when the ground beneath your feet suddenly shifts with the force of a freight train. That's not a movie scene. It's a very real possibility for the people living in Dawson City, Canada. Hidden beneath the tranquil Yukon landscape lies a geological giant, the Tintina Fault. For more than 12,000 years, it has been silent, but new research suggests it might be ready to wake up in a spectacular and dangerous way. Stretching over 1,000 kilometers from the Yukon into Alaska, the Tintina Fault is like a massive crack in Earth's crust, a boundary where colossal slabs of rock slowly grind past each other. On the surface, it looks harmless, just rugged terrain, rivers, and forests. But deep underground, strain is quietly building, like a spring being wound tighter and tighter. Theron Findlay, a geologist from the University of Victoria, and his team decided to take a closer look at a section of this fault near Dawson City. This wasn't just a casual inspection. They used cutting-edge tools like high-resolution satellite images, aerial surveys, and LiDAR, a laser-based scanning method that can reveal subtle changes in the ground's shape. What they found was unsettling. In one location, the ground was visibly displaced by an astonishing 1,000 meters, evidence of a long series of powerful earthquakes millions of years ago. In another area, they spotted a smaller but still significant offset of about 75 meters, likely caused by more recent quakes, roughly 132,000 years ago. Since then, nothing major. At least, nothing visible. And that's exactly the problem. When a fault line hasn't released energy for thousands of years, it doesn't mean it's safe. Quite the opposite. It could mean that massive pressure has been silently accumulating. Based on their calculations, the Tintina Fault has been moving at a slow creep of up to 0.8 millimeters per year. Over 12,000 years, that adds up to a staggering 6 meters of potential movement waiting to be unleashed. If that strain were to suddenly break free, the resulting earthquake could be bigger than magnitude 7.5. For context, that's in the same league as some of the most destructive quakes in history, like the 1976 Tangshan earthquake in China, or the 2010 Haiti disaster. While the Yukon isn't densely populated, the impact could still be devastating, damaging highways, collapsed buildings, landslides cutting off communities, and potentially loss of life. The scientists can't say when it will happen. Earthquakes don't work on a schedule, and predicting the exact moment of rupture is one of geology's greatest challenges. What they do know is that the Tintina Fault is in what's called a late stage of its seismic cycle, a point where the risk of a major quake is higher. For the people of Dawson City and surrounding areas, this means living with a quiet but ever-present threat. Emergency planners might advise residents to have evacuation routes, survival kits, and backup communication plans. But in the end, this is a reminder of a simple truth. Earth is never truly still. Even in the most peaceful landscapes, immense forces are always at work, reshaping the planet in ways we can't always see, until the day they reveal themselves with a violent jolt. Yet, the story of the Tintina Fault is more than a warning. It's a glimpse into how Earth stores and releases its pent-up energy. Each millimeter of annual movement is like another twist of a key in a lock. At some point, the lock will turn, and when it does, the release will be sudden and powerful. LiDAR images reveal ancient scars across the land, subtle to the untrained eye, but obvious to scientists. These are the footprints of past disasters, frozen in the ground like a history book carved by nature. Findlay and his colleagues believe the region's seismic silence has lulled people into a false sense of security. A place can be both beautiful and dangerous, and the Yukon is a perfect example. Visitors come for the sweeping vistas and endless wilderness, rarely realizing that deep beneath their hiking trails and scenic roads, forces are shifting that could change the landscape overnight. This hidden drama plays out all over the world. Fault lines in California, Turkey, Japan, and beyond all share one trait. They eventually break. The question is never if, but when. The Tintina Fault just happens to be one of the quieter players, which in geological terms can be far more ominous than the noisy ones. And so, the clock ticks, silently, in the frozen north, counting down to a moment no one can see coming.
Dinosaurs, big ancient bugs, creepy spiders, and scary insects are all cute animals compared to the monsters that lived on Earth about 500 million years ago. For example, here's a creature that swam in the water like a stingray and had 3 eyes. Its mouth was like a pencil sharpener. 2 long claws with forked tips like pincers protruded from its head, and its gills were somewhere in the back. This is not a thing from a sci-fi movie. This is Mosura. Its remains are preserved in excellent condition. Let's look at it more closely and study other similar monsters. The Cambrian Explosion. Remember this name. This period is also called the biological Big Bang, the time when a huge number of different living creatures began to appear in the ocean, large, small, and tiny. The ancestors of almost all modern animal groups were most likely born during the Cambrian Explosion, which lasted from 541 to 485 million years ago. It was a time when the first truly effective and terrifying predators appeared on Earth. One of them was Mosura. It's only the size of an index finger, but you would never want to meet such a creature while swimming in the sea. It's scary to imagine what it could do with its pencil sharpener-shaped mouth. And you probably wouldn't be able to hide from it because, come on, it had 2 eyes on the sides and 1 big eye on its forehead. Mosura belonged to a group of arthropods. Scientists called it a sea moth since it reminded them of a moth. This thing used a flap-like apparatus similar to wings to float in the water like a stingray. This monster was quite creepy, but its appearance may seem familiar because it's a distant relative of modern spiders, crabs, centipedes, and moths. Scientists found several 506 million-year-old Mosura fossils, but unlike many other similar finds, these ones have been preserved in excellent condition. The found fossils showed sharp claws, a toothy jaw, and large gills in the tail section. Some parts of the fossil were so clear that they revealed the details of the creature's internal anatomy, including parts of its nervous and circulatory systems and digestive tract. It had jointed limbs like those of modern insects and crustaceans. When this monster swam in the sea, it probably grabbed its prey with long spiked claws sticking out of its head. Many Mosura relatives have claws covered with multiple spikes, which help them grab food. But that ancient creature had smooth claws forked at the tips. That is, it grabbed the prey with those tongs, using them like chopsticks, and then brought it to its mouth. Of course, this is an assumption, and nobody saw how this creature actually did it. Unlike many other similar animals, Mosura's posterior segmented body was studded with gills. Scientists don't know why this was necessary, but they assume that such an unusual breathing system helped to adapt to an environment with low oxygen content. Perhaps Mosura led a very active reproductive lifestyle that required high oxygen consumption. Creepy, dangerous, and reproducing fast. An excellent set of qualities for one of the most dangerous predators of antiquity. But what did Mosura eat? It probably caught different types of worms and small arthropods. It's nice to think that this monster lived so long ago and was so small. But what if this creature was the size of a shark and was swimming in the ocean these days? Perhaps it would become a dominant dweller and people would swim much less along the coast. Mosura lived in the water but was discovered in the Burgess Shale rock formation in the Canadian Rockies. Many mountains on Earth were once the seabed inhabited by strange creatures. One of them was Opabinia. It had 5 eyes, a mouth facing backward, a long trunk and claws instead of a nose. Wait, what? It's too strange even for science fiction, even for outer space. In its eccentricity, Opabinia was perhaps the loneliest creature on Earth. Scientists couldn't find another species that would be similar to this individual until recently. Meet Utaurora. It seems to belong to the same species as Opabinia. Its inch-long body was divided into 14 to 15 furrows. Each of them ended in a pointed flap.
Opabinia had the same body, but it's unlikely that both monsters were friends. The difference between their timelines was several million years. It's hard to imagine why these monsters needed such strange body structures. Why haven't modern filmmakers used the design of those animals to create cool space monsters yet? Okay, they were creepy creatures, but what about weird and kinda useless ones? Scientists have discovered Su, a legless creature with no head turned inside out. Huh? This 444 million-year-old creature was found in South Africa, north of Cape Town. They called it Su after the discoverer's mother. In fact, it's some kind of new arthropod species that may have lived in low-oxygen waters. This creature was turned inside out, and the outer shell with the legs and head was lost. Thanks to mineralization, muscles, tendons, and even Su's intestines were preserved on the fossil. It's a great success to find such detailed remains of an ancient creature. However, scientists still can't determine the evolutionary history of this species. They're sure that it was a primitive marine arthropod. Okay, we can see that 500 million years ago, Earth was filled with creepy monsters, which fortunately are now extinct. But what about trees? Were they the same as we see now? Or was there something else? Something creepy? Oh yeah. Scientists have discovered a new kind of living organism similar to a tree or a mushroom. It was gigantic and had a very minimalistic design. Meet the Prototaxites. It's basically just a big stick with a round end poking out of the ground. It was smooth, didn't have the usual tree bark, and looked more like a mushroom without a cap. But scientists have recently found out that it wasn't a mushroom at all. Prototaxites probably belonged to a previously unknown branch of life. Prototaxites is considered to be the first giant organism in the history of the planet that lived on land. It existed about 420 to 375 million years ago during the Devonian period. It was the time when plants began to spread across dry land, forming large forests. Over time, they began to grow leaves and form roots in the ground. Then, the first seed plants appeared. The real colonization of land began. The first arthropods, such as centipedes, arachnids, and other unpleasant creatures, began to walk among those forests. Meanwhile, the water was filled with a huge biodiversity. There was a giant supercontinent on the planet, and smaller parts began to break off it. During this period, Prototaxites towered over the land. Some of these things reached 26 feet high and 3 feet wide. It's like a 3-story house and as thick as a palm tree. But what was it? A plant? A mushroom? Algae, perhaps? Scientists discovered them in the middle of the 19th century, but only in 2007 did they conduct chemical analysis. Research showed that it was most likely a giant mushroom, but in 2025, scientists refuted this conclusion. It turns out this may have been an unknown life form that existed separately from the kingdom of fungi, animals, plants, and protists. Scientists noticed that the inner part of Prototaxites consisted of a number of tubes. There are similar tubes inside mushrooms, but the tubes of that ancient living thing branched and joined differently. They even had a different chemical composition. The main building block of mushrooms is chitin. But the Prototaxites contained chemicals similar to lignin, a substance found in the bark of trees and other plants. And its anatomy differs from the structure of any other organism known to us. What were they doing on Earth? Just chilled and enjoyed the bloom of life? Did they produce some kind of fruit, like a banana with eyes and claws? Scientists don't know. What if it was something that was brought to Earth from outer space? What if they were flowers planted by another civilization? What do you think? Something is about to reshape the entire future of the West Coast. The coastline, the infrastructure, the whole map. Scientists fear there is not one but 2 big earthquakes coming, one caused by another. This wasn't even on the radar for most people, but new research is changing everything. For decades, everyone treated the San Andreas Fault and the Cascadia Subduction Zone like 2 separate monsters that just happened to live in the same neighborhood. They were powerful, yes, but independent. But now,
Scientists believe these two giant faults are mechanically linked, and one can literally pull the other into rupturing shortly afterward. Cascadia moves, San Andreas moves. San Andreas tears, Cascadia tears. And the potential consequences of that are honestly haunting. Scientists found evidence that it happened at least 10 times in the last 3,100 years. Earthquake, pause, earthquake. It comes from marine sediment cores, which are like time capsules pulled up from the ocean floor. Researchers analyzed layer after layer of seabed sediment and found doublets, paired debris layers created by two massive quakes happening so close together that the ocean barely had time to settle between them. That discovery takes us to the Mendocino Triple Junction, the geological troublemaker of the West Coast. It's the place where three tectonic plates crash and grind into each other like badly aligned gears. It's also the zone where the San Andreas meets Cascadia, which makes it the perfect place for these double quakes to form. The stress changes caused by a rupture in one fault travel straight through this junction and destabilize the other. It's benign when it happens to a bookshelf. When you move one book, three others shift. But when you think about it like a coastline with millions of people, entire cities, major infrastructure, it instantly feels terrifying. To many people who live on the West Coast, the San Andreas kind of feels like a California's problem, and Cascadia like an Oregon and Washington's problem. But when you understand that these two faults can essentially fire at each other, it stops being a local issue and becomes a continental one. A Cascadia megaquake alone can hit magnitude 9.0 plus, rip open 600 to 700 miles of seafloor, and send a tsunami roaring toward the Pacific coast. And it could just be the first quake, and then, maybe minutes later, the San Andreas snaps in Northern California. The shaking could ripple down the state like a zipper tearing open a jacket, and if it goes the other direction, it could be just as bad. If the San Andreas ruptures first, the intense stress redistribution can destabilize the Cascadia subduction zone. You could get the California quake first with buildings rocking, highways breaking, and power stations failing. And then, soon after, the ocean pulls back in Oregon or Washington. And the 20-minute countdown to a tsunami begins, a follow-up disaster. It's the kind of chain reaction you don't want even in a video game, let alone real life. This discovery also tells us something eerie about the earthquake in 1700, the one that sent a tsunami across the Pacific so huge that it struck Japan with no warning. Japanese fishermen called that wave the orphan tsunami because it arrived without any felt shaking. Only centuries later, scientists figured out that it came from the Pacific Northwest. But until recently, no one knew that the San Andreas might have felt that event too, and it possibly slipped or destabilized because of it. So, the whole West Coast may have moved together. And we've come to the scariest part. All this isn't about if, it's strictly about when. The faults have a rhythm, a pace, and a geological heartbeat. We've seen how they behave across thousands of years. We know what they did, and now we know they sometimes do it in sequence. The real fear isn't the first quake. California already expects a big one. The real fear is the second quake, the one that comes before you've checked on your family, before emergency responders regroup, before the power comes back, and before the dust settles. Even if you don't live on the West Coast, this matters for you too. The ports in California, Oregon, and Washington handle a massive chunk of America's imports. Knock them offline, and it's not just the coastline that feels it. The ripple hits the entire country, and potentially the world. Grocery prices spike, supply chains freeze, gas availability dips, shipping timelines go nuts. The world is much more connected than any of us thought, and a geological double punch on the Pacific coast wouldn't stay a local disaster. It would spread, thread by thread, into everyone's life. So, those in power must prepare not for one giant rupture, but for two. Emergency plans, evacuation routes, response times, and power grid designs, all of it needs updating. Because nature has now shown us what even a single major rupture can do to a modern economy. It happened in Japan in 1995, on January 17th at 5:46 in the morning. The quake hit right by the northern tip of Awaji Island, only 12 miles from Kobe, a huge, busy city with about 1.4 million people back then, and another 2.6 million in Osaka nearby. The rupture ripped along the Nojima Fault for about 25 miles. That doesn't sound like much until you realize entire buildings can't survive that kind of sideways shove. More than 5,000 people lost their lives. 43,000 were injured. Nearly 400,000 buildings were irreparably damaged. This disaster hit one of Japan's largest industrial zones. And when you mess with a place like that, the shock doesn't stop at the shoreline. The damage was $200 billion US in losses, from smashed buildings and infrastructure and many businesses shutting down. Kobe's port just collapsed. Only 30% of the Osaka-Kobe railway lines worked. Part of National Route 28 literally vanished into the ground. Schools, hospitals, and municipal buildings, 85% of them took damage or were unusable. Fires broke out across Kobe, almost 300 separate incidents, burning the equivalent of 70 US city blocks and taking another 600 to 700 lives. Almost 100,000 people permanently left the region, 2.5% of the whole population gone in less than a year. And here's a detail that stuck with me. So many bridges failed that engineers suddenly had to confront how poorly older designs handled lateral shaking. Houses with heavy tiled roofs, built to fight typhoons, crumbled because all that weight sat too high. But the newer homes made after the 1981 building code revision stood. And that's when Japan realized that modern seismic standards were crucial to follow. Japan threw $58 billion US into restoring the region. Power came back in days. Roads and rail returned in 5 to 8 months. The main expressway took 21 months. The port was fully rebuilt in just over 2 years. And by then, all debris was cleared. Within 15 months, manufacturing jumped back to 98% of its old level. Stores reopened. By 1999, Kobe's economy reached roughly 75 to 90% of pre-quake levels. Japan overhauled its disaster management system entirely. They set up the Central Disaster Management Council and rewrote building codes. They upgraded everything from emergency drills to fire-resistant city layouts, and they launched the Earthquake Early Warning System that now gives Japan those precious few seconds before shaking hits. The same system that saved countless lives since 2007. But despite all this improvement, the Kansai region still sits on dangerous ground. The Roku-Awaji-shima fault system, the same one that snapped in 1995, still runs under them. The 2018 Northern Osaka quake and the 2024 Noto Peninsula quake reminded everyone that this threat didn't disappear. It just waits its turn. A future large event on that system could hit even harder simply because the region has grown more complex, more interconnected, and more economically loaded. So Kobe wasn't even a triggered double fault rupture, but it still broke a major industrial hub, reshaped a national economy, and permanently changed global shipping routes. That's why when scientists started talking about 2 joint faults firing off back-to-back in Cascadia and San Andreas, you don't even have to imagine the consequences. We already got a preview in 1990.